uh, we can get maximum output and good. Miss Diaz, are you here?
Yes, Dr. Tanvir. Tess, hello, Dr. Tanvir.
Can you hear me, Diaz?
Yes, I can hear you, sir.
Yeah, thank you very much. So I think we are almost in time, 8 minutes in our hands. So um, as we discussed, is there any issue that you need to check with me? Or
Hello, good morning, doctor. Can you
yeah,
hear me?
yeah, Mr. Hadoizi, how are you? Thank you for joining with us.
Yeah. I'm fine, and I hope you well also. Thank you very
Yeah,
much.
yes, we are fine.
Yeah.
So thank you for joining with us. You are now in Jakarta.
Yes, I'm in Jakarta now.
Thank you very
What
much.
about you, Tokyo?
Yeah,
First.
I'm in Tokyo, but I am actually joining from my home because we are now work from home.
All right.
But hopefully the Secretary General will join from office.
Okay.
Yeah.
Okay. See you soon.
Yeah. Thank you very much, Mr.
Yeah.
Harris.
Hello, Dr. Tanvir. I'm Arjuna Velaran from Sri Lanka, Southern Provincial Minister of Agriculture Secretary. Have you started? No,
not yet. Well,
not.
No. We will start shortly. Only 2-3 minutes. Yeah.
Okay.
Thank you very much.
Check mic. Ladies and gentlemen, welcome to the International Conference on Climate Resilient Agriculture 2021. My name is Ning Tias, and it is an honor for me to be the master of ceremony of this conference. Right now, I'm wearing the traditional attire of Sumbawa called Lamung Pene to symbolize our warm welcome to all of you. First of all, I would like to thank to all of you, the participants, the presenters, and the fellow committees who have dedicated their best to make this conference happen. This conference is organized by the ASEAN Productivity Organization in collaboration with the Ministry of Agriculture of Indonesia and Sumbawa University of Technology. Distinguished presenters, participants, ladies and gentlemen, to formally kick off our event today, it is my pleasure to invite the head of National Productivity Organization of Indonesia to deliver his opening address. Please welcome Mr. Fahru Rozi.
Thank you very much. Honorable Dr. AKP Mohtan, Secretary General of Asian Productivity Organization, Dr. Zul Kefir Mansa, Governor of West Nusa Tenggara of Indonesia, Dr. Ade Chandra Dijaya, Director of Bureau for International Cooperation, Ministry of Agriculture, Mr. Hairul Hudaya, PhD, Rector of Sumbawa University of Teknologi of Indonesia, Dr. Saif Tafir Hussein, Senior Program Officer of Asian Productivity Organization, Dr. Arif Budi Widiarto, Director of Sumbawa Teknologi Park of Indonesia, Mr. Edi Sofiari, Director of International Engagement and Technology, and Collaboration, Sumbawa University of Technology, research persons, participants, ladies and gentlemen. On behalf of the APO Director for Indonesia, it is a great honor for me to have a meeting here with you all in this opening session. First of all, I would like to take this opportunity to to extend my sincere gratitude and appreciation to the Asian Productivity Organization, Sumbawa University and Technology, and the Ministry of Agriculture for collaboration in realizing this conference on climate resilience, agriculture in the COVID-19 pandemic circumstances. I would also like to take I also like to extend my appreciation to all distinguished resource persons and all participants that who attend this conference held in virtually because of existing condition. This conference involved participants from various countries under different time zone, and we are happy because there are 11 countries with 83 participants join into this conference. Ladies and gentlemen, the threat of climate change in unestablished evidence, it is affecting to livelihood and good food security in rural people around the world. Global climate change influences economic performance of all countries, but agricultural sector in generally the hardest in terms of the number of people affected. Climate change has a serious impact on the availability of various resources on the earth, on the earth, especially water, while sustain life on this planet. It was predicted also that climate change alter the rest hydrological resources and add pressure on the adaptability of future water resources. It has the potential to impact significantly on both the availability of and requirement for water supply. Ladies and gentlemen, with this conference and climate resilience agriculture, we believe that we can we can learn from experts, share knowledge, and the latest scientific knowledge and technological advance in achieving climate change resilience in agriculture with APO members. It is hoped that the conference will contribute to the important agriculture productivity and resilience and as well as more secure livelihood in member countries, and they address the major issue of climate change. I thank you very much. Kok nggak lanjut?
You have to unmute first.
Ms. Nignias?
First of all, I would like to extend my gratitude to the Asian Productivity Organization, APO, and the Ministry of Agriculture, Republic of Indonesia, for trusting us, Sumbawa University of Technology, to host this prestigious conference. I also would like to thank all the participants who earned their seat to be here, as well as to the committee for their hard work and dedications to organize this conference. I hope this conference will be an extended collaboration between UTS and all of the parties involved in this conference to tackle the most pressing issues face our community. Secondly, we are highly honored to host this event, not only because its global nature, but also its shared values and objective with our own. UTS is established to catalyze the development in Sumbawa region and the eastern part of Indonesia region and ensure that it goes along with the endeavor of the sustainability of our environment. When we talk about environmental sustainability, we talk about the future of our food security, the future of the space where we live in, and the future of human civilization. In UTS, we are committed to putting our best endeavor to participate in tackling issues around environmental sustainability amidst the challenge of climate change. We orient our works and their impact on our surrounding toward established resilience. We have just installed, for example, 25,000 watt peak of solar panel that supply the campus of electricity needs. Following the launch of our very own brand of electric motorcycle, we call it Ngeboots. It is an alternative vehicle that is more environmentally friendly. This because we are aware that one of the challenges of higher education institution in 21st century is maintaining their relevance to their environment. We are aware that our university operates within the globalized world and within the local dynamic at the same time. Therefore, we have just restructured our curriculum to encourage our students and also faculty members to connect and participate in the global sphere, as well as to involve in creating impacts on the local communities which is agricultural community. Our students, along with the faculty members, spend their one semester among the local community to learn firsthand their challenges in their agricultural practices and offer solutions they have learned from campus, such as creating organic fertilizer from the waste close to them. Last but not least, I'm delighted to finally greet all of you to this conference where I hope you will cultivate takeaways in terms of sharing knowledge, best practice exchanges, and planning potential action together. I'm delighted to wish you from the Olat Maras Valley, where our campus located, a great fruitful conversation. Thank you.
Thank you to Mr. Hairul Hudaya, PhD. And ladies and gentlemen, before we move forward, I would like to remind you to turn on the video and the microphone should be mute during this conference. Next is the last remark. Please allow me to invite the Secretary General of ASEAN Productivity Organization, Dr. AKP Muhtan. The time is yours.
Thank you very much. Greetings from Tokyo. I hope everyone can hear me. Assalamualaikum warahmatullahi wabarakatuh. A pleasure to join you, and my regards to Pak Harurozi, the Director of the Productivity and National Productivity Organization of Indonesia. Pak Rektor, greetings and thank you so much. The Governor of Sumbawa, and especially my appreciations to the participants and the resource persons. I recall that this conference was originally planned to be held actually face-to-face in the original planning, that we wanted to have it in both actually in Bali, then move on to Sumbawa. Very unfortunate that it was not able to materialize because of the COVID-19 restriction, because of the situation. But nonetheless, I am very happy that we can have this conference at least virtually. And I think there will be a lot of things to learn from one another as well. Let me underline the importance of this topic of the climate resilient agriculture. The agriculture sector is perhaps one of the most vulnerable sector when it comes to climate change. We have always known the pressure on agriculture in terms of the size, in terms of the what you call this, the population, the demand, and everything. But then this is all aggravated by the climate changes, and therefore this has become an urgent issue, and this is something that is need our collective efforts and also collective wisdom, as well as the pool of knowledge. I understand that the speakers, the resource persons from Australia, from India, from Bangladesh will present equal importance of exchanges of views and experiences among the participants. This will make the meeting worthy, and I therefore look forward to the successful conclusions and wish all a very lively, dynamic, conference for today. Again, let me close by thanking the Pak Fahru Rozi and the team NPO Indonesia, Pak Rector and the university, and to everyone, especially for joining this conference. Thank you so much and have a very fruitful and productive conference. Thank you.
Thank you, Dr. AKP Mohtan. Ladies and gentlemen, I would kindly inform you that now we are going to do a photo session, and this session will be divided into several takes since there will be several rooms on the screen. Make sure to turn on your camera and put your best angle. So if you are ready, on my count to 3. 1, 2, 3. Move to the next slide. 1, 2, 3. One more time. 1, 2, 3. The last but not least. 1, 2, 3. Ladies and gentlemen, before we move to the next session, please enjoy the corporate video of ASEAN Productivity Organization.
We are living in a time of constant change. In an uncertain and changing world, Asia must prepare to meet the productivity challenges of the future. The Asian Productivity Organization is here to help. With 20 member countries, we are a think tank, catalyst, regional advisor, institution builder, and clearinghouse for productivity information. In the coming decades, cultivating a culture of technological innovation will be key for economic growth and productivity in Asia. Adopting new technology can improve the efficiency of manufacturing, transportation, trade, agriculture, and labor. We give our members the information they need to take on new tools and policies. We encourage nations to share information because we are better when we work together. With the right tools and information, countries in the Asia-Pacific can not only meet global challenges, but lead the global economy. The APO will continue to lead with strategic and inclusive initiatives that are aligned with the UN SDGs. Building a more proactive, productive future for Asia. The APO, pushing the frontiers of productivity.
Some information that will be delivered by the officer in charge of this program. Please welcome Dr. Sheikh Tanvir Hussain.
Thank you very much, Ms. Nimtiaz. I first like to thank all the guests, speakers, and the participants for attending this conference. Actually, I will request the participants to put your any questions and comments while the conference will move. And please try to mute yourself so that there are no extra and outside noise is not come in the event. And I will assist Ms. Nimtiaz and Mr. Eri Sophia III, the director of Sumbawa University of Technology, and he will actually coordinate the all discussion. So I will assist Mr. Eri while the discussion will be happen in after each presentation and also the panel discussion time. So with these few words, I like to request all the participants and look forward to a very inclusive and very participatory discussion in this one-day conference. So thank you very much. And I like to hand over to Ms. Ningtyas. Thank you very much.
Thank you, Dr. Tanvir. Before we proceed to the presentation, allow me to inform that we will have 5 presentations that will be delivered by 5 resource people. The first presentation will be given by Dr. Arif Budi Witarto from Indonesia. He is the director of Sumbawa Technopark, and the topic that will be discussed is role of Technopark to support sustainable farming in UNESCO appointed biosphere reserve of Samota. And the second presentation will be given by Mr. Andrew Liu from Australia. He is the International Director of Regeneration International. Topic that will be discussed is regenerating soil to increase adaptation to and mitigation of climate change. And then our third presentation is about participatory assessment of climate impacts on agriculture and social enterprises. And it will be given by the Global Lead of Climate Change Action Aid International, Mr. Harjit Singh from India. Moving forward to the fourth presentation is Collective Extension Approach to Climate Smart Alternate Wetting and Drying Technology. And it will be delivered by Dr. Ahmad Salahuddin from Bangladesh as the consultant of International Rice Research Institute. And the last presentation will be delivered by the Coordinator of Regional Development Acceleration for West Nusa Tenggara, and also lecturer at Graduate School of Environmental Science of Udayana University, Mr. Ida Bagus Windia Adnyana, PhD. And each presentation will be ended by 10 minutes discussion, and this session will be led by Mr. Eri Sofiatri. And next, we will have 35 minutes plenary session or panel discussion. And lastly, the closing remarks that will be given by Dr. Ade Chandradijaya from Indonesia. So, ladies and gentlemen, we are now about to start the panel discussions, and it will last for 10 minutes for each presentation. So please welcome Mr. Eri Sofiatri.
Thank you, Ms. Ningtyas, for your time. And my name is Eri Sofiatri. I'm the moderator of this session, moving forward to the panel discussion. And actually, it is not a panel discussion yet. So this first session will be presentation from Dr. Arif Budi Witarto. He's the director of Sumbawa Technopark, the local government-owned technopark, sharing with us how actually like local innovation built in Sumbawa, especially in agriculture. So Dr. Arif Budi Witarto, you have 30 minutes to present your presentation, and then later on we will have a 10 minutes discussion afterwards. So Mr. Arif Budi Witarto, time is yours.
Thank you, Mr. Moderator. Can you show me? Can you show my slide presentation? Because I cannot do share screen from my. Okay. Good morning. Assalamualaikum. Peace be upon you. First, I'd like to thank the ASEAN Productivity Organization, Indonesia Ministry of Agriculture, and Sumbawa University of Technology for giving me the opportunity to share our activities and experiences today. Ladies and gentlemen, my title is as shown in the slide, beside the director of the Sumbawa Technopark, I'm also the chairman of the Sumbawa Regional Research Council. Next slide, please. Next slide. Yes. Okay. First, I like to introduce what the Technopark is. Technopark program in Indonesia is a national program under the presidential decree in 2017. And Technopark is designed neither as a research institute or educational institute. Instead, the objective of Technopark is to create startup companies through incubation process, providing common facilities for tenant, so it can help the growth of economic in the regions. So the return, please return. Yes. So in the right, I showed the kickoff program in 2015. The Indonesia government has target of 100 technopark to be built in Indonesia. Next. So here I summarize the number of technopark in Indonesia. As a national program, there are 7 ministries and agencies being asked to establish the technopark within their institution or coordination. First, the Ministry of Research, Technology, and Higher Education, or Ristekdikti. The Sumbawa Technopark is one of these technopark coordinated by the ministry. And then Ministry of Industry, Agriculture, Maritime Affairs and Fisheries, the Agency for Application and Assessment of Technology, National Nuclear Energy Agency, and Indonesian Institute of Sciences. So you can see in 2015, target is 100, but by time in 2019, actual number is 38, and plus 2, which already established before. So now the number in total is 40. Next, please. Here is the map of Indonesia. The color showed 34 provinces. I put the location of these 40 technopark. You can see Java Island, the main island of Indonesia, where the capital located. There are 58% of the technopark. And next is in the left is the Sumatra Island, the next big island. There are 9, and the rest 8 technopark or 20% is in the east part of the Indonesia, including Sumbawa. So although the initial plan is to help less developed region like east part of Indonesia, but in reality, at this first phase, still in the center of Indonesia, like Java and Sumatra, is the majority of the technopark are located. Next, please. Next. In this slide, I showed you the types of technopark in Indonesia. First, based on the ownership, there are 4 types of technopark. Majority is owned by local government, either province, city, or regency. The number is 26 or 65%. The reason why this type of technopark is majority, because the original plan is to help develop regional economies, and the funding comes from the central government. So this type include the Sumbawa Technopark owned by the Sumbawa Regency. Next is the Technopark owned by, return please, public universities. There are 9. The reason is because there are a lot of source of innovation there. Many lecturers doing research, they have a patent and so on. Then central government agencies and private. Private is very small, so far only one in Cikarang Industrial Park, serving the tenant companies in the industrial park. Then types based on priorities, I can divide into two based on technology, like the information technology, there are at least three, and life science, agriculture, biotechnology, this including Sumbawa, and based on commodities like oil palm, there is PPKS in Medan, Pelalawan in Riau, and coffee and others. So this is the types of technopark in Indonesia. Next, please. Next, I will make an introduction about the Biosphere Reserve, especially for you whom has never heard about this program. This is the program by UNESCO. In the left, you see the certificate showing that Saleh Moyo Tambora, or abbreviated as Samota, in Indonesia has been designated, appointed as the Biosphere Reserve. So in Indonesia, until 2019, there are 16 Biosphere Reserve. And according to the official website, Biosphere Reserve objective is to place for learning sustainable development with the three functions: conservation, second, economic development, and third, logistic support, including research. So in the bottom, I showed you several unique animals in the region, like parrot, yellow-headed parrot, whale shark, coral reef. Next, please. This picture I took by drone showing the Saleh Bay. It's a bay in the Sumbawa as the core zone. The core zone is the the essence of the Biosphere Reserve, and there is a Tambora volcano, also a core zone, and there are bagang in our local language called the sip, used to catch the fish, and we can see a whale shark there. So this is a representative view of our reserve called Samota. Next, please. This is a more detailed view because in the UNESCO Biosphere Reserve, they constructed three types of zone. First, the core zone, which is in the red. You see, I put naming there Tambora Volcano, Satunda Island, Moyo Island, and other islands. And the dark green, this is a buffer zone, and the light green is the transition zone. So Samota Biosphere Reserve comprised of this land region as well as sea region. And the Sumbawa Technopark is located just in the transition zone, very near. So I can say that among the 16 biosphere reserve in Indonesia, we are the technopark located inside the biosphere reserve. Unfortunately, there is a massive deforestation in this transition zone, especially for corn plantation, which is of course not sustainable. I showed you two pictures as representative. You can see that the forest is completely gone, and they are used for corn plantation in Sumbawa Island and also in Moyo Island. And so we see that our technopark, which the function is to create startup companies, we try to direct it to company which produce product and service supporting the sustainable farming, either in agriculture, aquaculture, and livestock. Next, please. So now I like to show you some startup companies created by Sumbawa Technopark, which has products, services supporting this sustainable farming. Next, please. First is the tenant company in our language called the Naga Horticultura. Is the startup companies using greenhouse, which is the common facility in the Technopark, producing agricultural products, focusing with less water and without soil medium. So using drip irrigation and cocoa peat medium and hydroponic. So one of the main product is the melon with 15% bricks, and it's been sold in the Sumbawa, also to other region in the island. And next is another tenant called Sumbawa again NTB. This is a startup companies providing genetic tests for prawn or shrimp aquaculture using organic farming. So the company only use the probiotic. So they need to check always their potential infection from virus or other pathogens. So we provide the test. And this company also now running COVID-19 genetic test as a national reference lab. The facility used is molecular biology. Next, please. Next, there is a tenant company called Alat Permesinan Sumbawa Mandiri. So far, this company has two products currently commercial. First is the chopper in the top figures. So this chopper is used by local farmers to cut the corn stem, become smaller so that it can be fed to the cattle. So the local government already bought these machines, and now the farmer also buy our products. And return, yes. The other is producing the auto feed in the bottom picture. This is used to feed prawn in the pond, replacing current practice which person give directly, so may give potential infection bringing pathogens. So okay, so this tenant work in the machinery products. Next. So our last example of tenant companies is Cipta Kerajinan Sejahtera. The startup companies use the small medium-sized plant facility producing the refined kerajinan using technology which use less fresh water during washing process, because in Indonesian standard industry, it has to go through the semi-refined, but we can directly go to the refined kerajinan. The product is shown below. It has gel strength, industrial level. So it's the company now look for the buyer of these products. Next. So what we learn from organizing this technopark in region, Sumbawa is far from Java and has less infrastructure and so on. So we saw that we have a business idea call for proposal. We call it the bottom-up process selection for new tenant. Unfortunately, it has not been so successful because the majority of participants and winners are students, lecturers, alumni. We are really good in producing prototype, but still unable to focus on marketing and selling. We show that we have less quantity and quality in terms of experience in regions when compared to the technopark in the big cities. So we have another approach, top-down process approach. What we do is we find the market first, and then we find the source of technology, and then create the company, then find persons to do, then technology transfer, and nurture this person to become the entrepreneur. Yeah. Next, please. So I summarize in this picture the sentences I just mentioned. So we then saw that the top-down process is quite successful in our condition. However, bottom-up process still very important. So we see that we need improving the human resource in terms of innovation. Next. Yeah, that's why in 2017, Sumbawa Technopark, in a special agreement with the foundation on the University of Technology Sumbawa, initiated and created the Master Program of Management of Innovation. Again, the objective is to provide the sufficient human resource with understanding and innovation. Next, please. Next, yeah. And we also have an international program such as the internship in Tokyo for 6 months, and also sending our students to visit institution, companies, and research in ASEAN countries, because our student majority, they have their own business, so they have to make a contact and compare their situation with others in abroad. Next, please. Yeah, this may the last slide. So we are choosing the open innovation approach as an inclusive way to get the tenant into the Sumbawa Technopark. So you see in the right figure, Sumbawa Technopark as an institution have 3 open facility. So the tenant can be incubate inside or in wall or outside of wall. So we get funding from the ministry to promote this activity to other region in the Sumbawa Island, and even also to other provinces in east part of Indonesia. So we learn from disruption era, like I showed in the left part of this slide. When we go exclusive, it's easily defeated by some inclusive platform, and so we have to adapt this in our situation also. Next, please. Next, yes. So sorry, yeah. So in conclusion, Sumbawa Technopark is one among 100 science and technopark to be built in Indonesia. We have been able to support sustainable farming, especially because we are situated or located in UNESCO appointed biosphere reserve called Samota, which has a goal of learning place for sustainable development. So it's an obligation for us to support this sustainable startups. So we do this by creating startup companies, providing product and services in agriculture, aquaculture, and livestock, as we shown before. And by using top-down approach in parallel, by preparing qualified human resource in the region, Sumbawa Technopark has been nominated by our ministry with a big qualification, which is few among local government. So Indonesia government has ranked among the Technopark. So fortunately, we are among the good part of this Technopark. And finally, we see that open innovation has also been successful in Sumbawa Technopark, so it can be applied also in other region or similar facilities. Next, so that's all. Thank you for your attention. Below is my email contact. Thank you. I return to the moderator.
Thank you, Dr. Arif Budivitarto, for a very detailed presentation on how actually Sumbawa Technopark has established an innovation endeavor and ecosystem in local region of Sumbawa, especially when it comes to preserving the Samota biosphere. So here I'd like to invite all of the participants to ask questions. You can chat it to the chat box. All right. I have one question from Jonathan Galindles from Philippines. The question is, what are the involvement of the people in the nearby areas of this technopark? How do they benefit from it? So the involvement of a surrounding community and how they benefit from the technopark. Dr. Arif, time is yours.
Yes. First, the surrounding people benefit directly from the product and service given by the tenant companies, because this the organization, the companies which create the product. So like the chopper, which used for the make the cattle feed, has already been used by the surrounding farmers. And although of course at the beginning major customer is the companies, because they are the one who has purchasing power, like the shrimp genetic test and the auto feed and others. And second, we also have program to find the local, we call the genius, because some of villages in Sumbawa, they have products like we found one village in Tepal, they produce the micro hydro turbine. So we invite them, and using our machinery workshop to make their micro hydro turbine, and in process for standardization. So maybe they can sell it outside the region. It's already been sold about 5 units in surrounding village. Thank you.
Thank you, Dr. Arif, for your answer. And I hope this satisfies you, Mr. Jonathan. It is unfortunate that I cannot be offline and then we can return back for you to respond. I think if you have any further question on Dr. Arif, we still have a panel discussion later in the end of the presentation session. So you can save the question for that. And then now we are moving forward to the next presentation. So the next presenter is Mr. Henry Liu from Australia. He is the International Director of Regeneration International. He will be presenting regenerating soil to increase adaptation to and mitigation of climate change. So this will be very technical about soil and land and how that actually like agricultural practices has been jeopardizing our environment. So Mr. Henry Liu, time is yours.
Terima kasih, and thank you very much to all the organizers. This is, I think, a very important conference because climate change is an existential threat. And as we've heard from the previous speakers, it particularly affects agriculture, and Asia. Farmers in Asia are amongst the most vulnerable. Can I share my screen, please, for my PowerPoint? Okay. Thank you. Okay, look, thank you very much. So we've seen the title, so we'll just go on to the next slide, please. Okay. What I want to show on this slide, if you look at the top graph, what you'll see is 800,000 years of carbon dioxide. And last year, the world set a new record of 417 parts per million. We have never, ever had that level that we know of, not in the last 800,000 years. And even if we go back to 3 million years ago, 3.5 million years ago, the world was between 5 to 16 degrees warmer. And there's actually several studies published in the scientific journal Nature to show this. 5 degrees was the minimum, and that's at 380 parts per million. We have already passed that. The studies show that sea levels were between 20 to 30 meters higher than they are now. The carbon dioxide levels have been increasing between 2 to 3.3 parts per million since the Paris Agreement. In other words, despite the Paris Agreement, it's getting worse. And at the current rate of what we're doing, the Paris target of net zero emissions by 2050 will mean that we are close to 500 parts per million. Next slide, please. But what is really important to explain is that the legacy carbon dioxide, the carbon dioxide we have in the atmosphere now, will remain there for hundreds of years, even if we meet zero net emissions. It'll take a long time for it to get out of the atmosphere. What that will mean is the world will continue to heat up. And what is very important to explain here is that this extra energy is the equivalent of millions of atomic bombs worth of energy. If you just think in terms of how much heat we need to heat up our oceans and our planet by 1 degree, 1.5 degrees, that's where we are now. That is the equivalent of millions of atomic bombs of energy. And I'm using this violent metaphor to understand, for people to understand why we are now getting violent and extreme weather extremes, such as storms, droughts, fires, floods, crop failures. And just to use last year as an example, the typhoon season in the Pacific, in the North Pacific, for Philippines, for Vietnam, and other countries. You can move to that slide, that's right. It's fine, the next. To explain that typhoon season was the worst in history, some of the most destructive and largest, and it's only going to get worse. And the global sea level rises will cause all the atoll islands in the Pacific and Indian Oceans to disappear. Those countries will no longer exist. Most of Bangladesh won't exist. And if you want to talk about our major cities in our region, like Tokyo, Yokohama, Manila, Bangkok, Calcutta, Jakarta, Shanghai, Singapore, what happens when they go underwater? We will be having a refugee crisis of hundreds of millions of people. We can't cope with a few million refugees now. The world will not be able to cope with this onslaught. So, yeah, next slide, please. It's fine. So what we need to do is draw this carbon dioxide out of the atmosphere. We need to go to negative emissions now, not near, net zero. And the way to do it is through soils. Soils are the greatest sink after the oceans. Most of the carbon goes into the ocean, and we already have too much there. It's causing ocean acidification. It's affecting our coral reefs and other parts of the ocean ecosystems. We have around 2,700 gigatons of carbon in soils. We have around 575 gigatons in wood, in other words, in forests, and the atmosphere around 900 gigatons. In other words, we have around 3 times the amount of carbon in the soils than in the forests and the atmosphere combined. So it'd be most logical for us to remove the carbon dioxide out of the atmosphere and put it into the soils where we need it. Next slide, please. So what we want to say here is that what we actually need to do is draw down around 25 gigatons of carbon dioxide out of the atmosphere per year, just to stabilize at 417 parts per million. If we can draw down more, we start going into negative emissions. So the next part of the slide, I actually want to talk about the good news, how we can do it, how we can take this out through agriculture. So next slide, yes, please, the 4 for 1,000. Probably the most important initiative, as far as I'm concerned, in the Paris Agreement was on December 1, when the French government launched the 4 for 1,000 initiative. And what this is designed to do is take agriculture, to take farming from being a major greenhouse gas emitter to being a major mitigator by using photosynthesis, by taking carbon dioxide out of the atmosphere and putting it in the soil as soil organic matter. And I was actually, when I was president of IFOAM, one of the original signatories of this document. So was Japan. This document is part of the actual Paris Climate Change Agreement. It's called the Lima Paris Accord and is recognized by the United Nations. We have 32 countries that have signed this. We have United Nations organizations like Food and Agriculture, the Global Environment Facility, the CGIAR group of research stations, and hundreds of NGOs have signed. And the whole idea is to take farming from being a major problem to a major solution. Next slide, please. And how do we do this? It is by maximizing solar energy. We get, when plants photosynthesize, they get carbon dioxide and water. Next slide, please. And through photosynthesis, they combine it to produce glucose. Glucose is the basis of the food system for most life. Next slide, please. This is the basic, chemistry, where we get 6 molecules of carbon dioxide, the main greenhouse gas, 6 molecules of water. We use solar energy through photosynthesis and make 1 molecule of glucose, and the byproduct is 6 molecules of oxygen. Most of the oxygen in our atmosphere has come from billions of years of photosynthesis. But when we look at a plant, between 95 to 98% of its biomass, in other words, what we see in a plant, comes from water and carbon dioxide, basically from glucose molecules. Next slide, please. Because what plants do is they actually use glucose to make sugars, carbohydrates, hydrocarbons, amino acids, other compounds. For instance, cellulose, which is wood and leaves are made from are long chains of glucose. Glucose is the basic molecule of life, and it all comes from photosynthesis. Next slide, please. When plants grow, about 30% of these carbon compounds that they make, that they take from the carbon dioxide in the atmosphere, they secrete into the soil. It's called the liquid carbon pathway or the carbon gift. They actually put these compounds, carbon compounds, into the soil as soil organic matter. Next slide, please. Yeah, thank you. And what I want to show here is very important to actually understand how we are changing farming with this knowledge, with this new technology. Everybody thinks that plants feed from their roots. But remember I said that 95 to 98% of a plant's biomass, in other words, what you see with the leaves and roots, its biomass actually comes from water and carbon dioxide and transformed through solar energy through photosynthesis. So if you have a look at the grass on the right-hand side, you can see it's got its full component of leaves and roots. As we cut the leaves, the plant loses roots. It does that because it actually feeds through its leaves. That's where it gets the sugars. When we cut leaves, it has less sugars to feed the roots. So rather than starving the roots and dying, it sheds off the roots in proportion to the leaves. So if we look at the plant on the left-hand side with the short leaves, it's now lost most of its roots. We can actually use this now for regenerative agriculture, for a new form of agriculture. If you look at the plant on the left-hand side and see that the leaves have been cut, it's shed off its roots. Think about the amount of organic matter that those shed roots have now put into the soil as they break down and they generate nutrients and feed the soil. So next slide, please. So we're using this now for new forms of agriculture. Instead of plowing out the other plants as weeds, we now can manage them by cutting down their leaves and allowing them to shed their roots into the soil. But our crop, which is what we call the cash crop, we want that to have access to light. So it's taller, because in the end, it's carbon dioxide and photosynthesis, and its roots are deeper. So it's getting the water and the nutrients. So it has the advantage over the other crops. Yeah, please, next slide. This is a rambutan orchard. It's actually my rambutan orchard, and it's my wet season now, and this is what it will look like at the end of the wet season. We call this a cover crop. I grow and I let it get very tall. In this case, I've got my tractor in there to cut it down. But I want you to imagine the picture of that grass and all the roots. So what you're seeing on top is also below in the soil. So when I cut that down, all those nutrients are going into the soil. I'm also capturing a lot of carbon dioxide. Next slide, please. This is what my place looks like in the dry season after I've cut down that cover crop and fed the soil. And in the case of my farm, I increased my soil organic matter from 1% to 6% in 11 years. I also increased most of the nutrients through this process without having to actually buy them as fertilizer. And I don't have time to go into details here, but we have other material on how to do this. I just want to show you what we are doing now with these new techniques. Next slide, please. So this is an example of what we call pasture cropping in Australia. Instead of ploughing out the ground cover, what we do is cut down the ground cover so it's very short. If you remember the picture of the grass before, when the leaves are cut very short, the roots break down. We can actually plow, plant into this. In this case, they do it in winter, and they're growing oats. It grows up. They're getting the same yield as the farmers who plow up, use lots of diesel, use lots of fertilizers, use lots of herbicides. In this case, there's very little energy, very little money expended. In the beginning, you put a little bit of phosphorus on. Now he doesn't put anything on. He gets all the oats. And when he takes off the oats, he has a pasture underneath to feed his animals as well. So it's got two crops. Next slide, please. This is the soil based on work, research done by Dr. Christine Jones, showing the increase in carbon that they've done with this compared to the block next door. It originally was the same farm, the two brothers. They've divided the farm in half, and you can see that the pasture cropping side now has captured far more carbon and built up the fertility. Next slide, please. This is another example of the same system. This farmer, Niels Olsen, has developed a more efficient way to actually basically break up the roots in the perennial pastures to plant in the cash crop into the pastures. Now, in this case, he's achieving very high yields in terms of his crops. But what I want to talk about here is drawing down carbon dioxide. He has been under the Australian government's carbon farming initiative. It's been verified that he's drawn down 2 years ago 11.2 metric tons of carbon dioxide per hectare, and last year he was paid for 13 metric tons of carbon dioxide per hectare by the Australian government. Just quickly, what this means, if we were to extrapolate this by the United Nations Food and Agriculture, agricultural soils, this system alone could sequester 55 gigatons of carbon dioxide. That's more than twice what we need to do, for 25 gigatons to remain net zero emissions. Next one, please. Next slide. Here's another technology developed by Dr. David Johnson of New Mexico State University in the United States. His research showed that they managed to draw down 37 metric tons of carbon dioxide per hectare per year. If we were to extrapolate that across agricultural lands, that's 184 gigatons. Now, what I like about this, this slide's good. There's also substantial increases in yield. This is actually in New Mexico, which is actually upland, semi-arid areas, very similar to actually the climate in Iran, for instance. But it can be used across any climate, and it can be done and on small scales, any size, smallholder farmer. It's technology that could easily be upscaled. And I was thinking about the previous speaker. these sort of composting systems would work really well in a technology park and could be used for all farmers to increase their yields. Also be used to draw down carbon dioxide and make farming greenhouse gas negative. Next slide, please. This is a small scale farm in the United States. It's 2 acres, which is less than a hectare. And they're using what we call a no-till, no-kill system. They're not plowing, they're just putting compost, planting into compost and mulch, and getting very incredibly high yields. But in terms of if we were to extrapolate that system by the amount of carbon dioxide that they could pull out of the atmosphere into the soil, that's 179 gigatons. Now, why I wanted to use this as an example is because in Asia, most farms are smallholder farms. They're 2 hectares or less. And this technology is very easy, is very applicable and can be applied. And what is really importantly, it will dramatically increase yields. That is really important as well, what we're talking about. Next slide, please. This is looking at rangelands grazing. 68% of designated agricultural lands are rangelands for grazing, and most of them are degraded. And we have regenerative grazing, holistic grazing systems now that will regenerate these systems and improve their water infiltration, their stock carrying capacity, and very importantly, their biodiversity. You know, we regenerate the habitats. Next slide, please. This is a peer-reviewed paper that looked at 3 of these systems. I'm not going to go into all the details. I'll put the maths there so you can actually check it for yourself. I just want to say that if we were to implement these new grazing methods on the world's rangelands, we could sequester around 98 gigatons, around 3 times what we need to do. Next slide, please. So what I want to explain here is that just transitioning a small proportion of agriculture to these best practice regenerative systems, and I'd like to say I'm only showing you 3 of them here, 4 of them really. We have many more examples that are applicable to all agricultural systems. But just if we could just look at 10% adoptions, which I believe is very achievable. In other words, 10% using the bean compost, or 10% using the Singing Frogs Farm system of no-till, no-kill, or 10% of rangelands starting to use regenerative systems to regenerate these rangelands, we could sequester around 46 gigatons, which is around around double what we need to do. In other words, just by trying to get a 10% adoption, we could be reversing climate change and bringing climate change back to where it needs to be. Next slide, please. And I think what is really important to put across here is that this is actually achievable. You know, we could reverse climate change. We could go to negative emissions. And I think what's really important here is we're not talking about inventing new technologies. We're talking about technologies that are already existing, that are already out there and being used by farmers now. All we need to do is scale them up and, just adapt them to our climates, our countries, our systems. That is what is really, to me, what is really good news. We have the ability to reverse climate change, and use agriculture to do it. And really importantly, produce higher yields of healthy food without toxic chemicals. So it is a good news story. So I'll end there and say, look, terima kasih banyak. I really appreciate you taking the time.
You can directly address your question direct to the chat box, and we can read it to the presenter, and we have a discussion. Okay, we have one question from Mr. Wait, I need to get the name. Okay, Mr. Sadman Faisi. So this method at scale of field or farm is verified. But when we want to do this for about huge areas, it's not acceptable. In other words, your work for small scale is true, but in a larger scale, do you have any pattern? That's a question from Mr. Saddam. So Mr. Andrew, you can respond to that.
Yes, thank you for a very good question. The pasture cropping examples I showed you, these farms are, hundreds of hectares. So they're not small farms. And at the moment, we actually have many farms around Australia and actually around the world adopting these. And we're talking already hundreds of thousands of hectares under these processes. Similarly, we're seeing the same with regenerative grazing now, where once again, we're starting to get hundreds of thousands of hectares adopting these systems. The other ones, such as the composting system and the Singing Frogs Farm, what we need there is to get proper training programs for essentially what we call farmer to farmer systems to teach farmers how to do it. And it could easily be scaled up. The thing is about all of these is that we don't need any really large technology. We actually need trained people to do it. We need to get a train the trainer program and teach people so we can actually teach farmers how to do it. That's not a large cost. It could be done very easily with all the existing infrastructures that we have in our countries.
Mr. Henry Liu, for your answer. We still have 4 minutes to go to close this discussion session for the second presentation. So if you still have any question, please address them to the chat books and I'll read them to Mr. Henry Liu. All right. We have yes?
Sorry, can I just one other thing?
Sure.
All right, okay, I've got a question on being. I just wanted to say one thing and talk about scaling up is that a lot of countries now, the governments have programs to adopt it. Like my country, Australia, they have a carbon farming initiative. President Biden has just announced one. Norway has one. New Zealand's just announced it. We're actually seeing governments now leading on this. So I'd really love to see governments in Asia doing the same. And then the question on being, look, we're in the process of working with various universities to get that scaled up. If you email me, I can Dr. Tanvir has my contact details. I'm very happy to send people the details about how to do it and how they can actually, do it themselves on their own farm, on their own unit, their own institution, and put you in contact personally with Dr. David Johnson, who invented this process. He'd be more than happy to help and assist you to do this.
Thank you, Dr. Andre Liu. Please, Mr. Mansour, you can directly be in contact with Dr. Andre Liu to get the detailed and then to be with the right, to be contacted with the right person. And next question will be from Mr. Asif. So in order to do this, financial will be a huge problem to adapt the solution, that is his opinion, for a big change. Is it possible to do so without government funding in underdeveloped countries? So that's a question from Mr. Asif from Pakistan. Mr. Andrew, maybe you can share your point on that.
It's once again, a very good question. Thank you for asking it. Look, yes, it is possible, and in our organisation and others, we are working as NGOs, but where we can get government funding, it's going to work so much faster and so much better. And not just the funding, but to actually work with existing infrastructures that the governments have. We can speed up the process. So it'd be so much better if we could get government funding, but we're not going to stop the lack of government funding from doing it. Everywhere we've started with our governments, and as we've become successful, governments have followed, because in the end, governments like to get behind successful programs.
All right. I hope that satisfies your question, Mr. Asif. And we still have 1 minute to go, actually. And the BEAM question has been answered. And then if there is no more question, I'd like to move to the third presentation of today's conference. Before we proceed, though, I'd like to remind you again to keep your microphone in silent position. And then also, if you have any questions related to the upcoming presentation, you can prepare them since from now on, and then put them in chat box. And if you have a further question from previous presentation, you can keep them, and then I will try to incorporate them into the next panel session. So moving to the third presentation of today's conference, we have Mr. Harjit Singh from India. He will be sharing the experiences of best practices in India, actually. So this presentation will be titled Participatory Assessment of Climate Impacts on Agriculture and Social Enterprises. Harjit Singh is the global lead of Climate Change Action Aid International. So, Mr. Harjit Singh, you have 30 minutes to present the materials, and then participants, you can address directly the question box, compile and read them to the Harjit. Mr. Harjit, please, time is yours.
Thank you very much. Good morning, everyone. And it's a pleasure to be part of this conference. And some very useful presentations and speeches I've heard this morning. So as my presentation, so should I put that presentation myself, or somebody's going to display? Yeah. So as my presentation title is Participatory Assessment of Climate Impacts on Agriculture and the Role of Social Enterprise, I don't need to build a background in the last few presentations. We have heard how, I think there is a tool coming on the left top corner. If you can press escape, it will disappear. Otherwise, it will hide some of the text. Could you please remove that? There's a tool appearing on the slide. This full screen tool. I think if you escape, it should go away. Or you put the presentation again. Yeah, that's right. Thank you. So my previous presenters have already talked about the impact of climate change and vice versa. We need to understand when we talk about agriculture, it's not only responsible for causing climate change, it's also a victim of climate impacts. And since this part has been covered, how agriculture is impacted as well as how it is causing. So I'm not going to go in a lot of detail, but just to put these keywords in your mind, that how deforestation has been happening to expand agriculture, particularly in Amazon, as you can see the data on the screen. Similarly, the water use that we have seen, for example, one hamburger requires 660 gallons of water, which is equivalent to, a shower by one person for 2 months. So that's the kind of water usage currently involved in our food system, in our agriculture systems, and which is absolutely unsustainable. As population increases, as we have many more people to be fed, and productivity goes down due to climate impact, it's really important for us to look at our model of agriculture. And climate change is also becoming a threat for agriculture production. There's huge amount of waste happening. So the whole system that we are operating right now of both food and agriculture must be reviewed. Next slide, please. This is a very interesting flowchart by UNFAO. I'll briefly talk about it, and of course you'll have a copy of presentation so you can go through that. As you can clearly see how the greenhouse gas composition has been changed over time because of industrial pollution, and we have seen how that is directly responsible for impacting agro ecosystems. And then that is causing climate change. Because of that, you see temperature going up, sea level rising, and you also see precipitation and a huge amount of variability that we have seen over the last few years and decades. Climate change also directly causes land degradation, which is linked to the impact on agro ecosystems in terms of different kinds of pests that we are seeing. We also see diseases increasing. We see how cultivated plants, livestock, forest, aquatic species, every aspect of that ecosystem is actually getting affected. And then because of climate change, there are also extreme weather events which are affecting agriculture production. Next slide, please. So this is connected one. And when you see that agriculture production post-harvest, there are a number of things that directly get affected. Prices go up because the quantity goes down. So clearly a demand supply gap. But we have also seen how the quality of the food we are growing is also going down. And the way markets get involved, the way trade happens, we see agriculture incomes are also going down while food prices go up. And they directly impact food availability, access, utilization, and stability. And that's not only linked to food security, but also nutrition, which is also a major crisis, but we are not talking about it enough. So that's the flow chart. I don't think, next slide, please. I do not think I really need to go into the details of declining crop production. Dr. Andre referred to that briefly. So these impacts continue to grow, and you can see how there's a constant reduction since 1960. Next slide, please. Another slide to show how food production is going to go down by 20, 30, and 50. So the previous slide was much more about past and what's happening right now. And this one is about future, how we see the impact of climate change on food production. Next slide, please. Now, I would like to spend most of my time in talking about participatory methodology. In the previous presentation, there was also a discussion around top-down approach, bottom-up approach. So in this case, we have particularly looked at how we can involve communities, people, to assess loss and damage that is already happening due to climate change. And the methodology toolkit that we have developed not only looks at economic, but also non-economic aspect, which communities are already facing. So with this participatory methodology, communities are able to understand the trends and as well as they are able to take action to avoid or reduce future disasters and losses. Now, because this tool gives them clear information, not only at the local level, but also to national authorities, it also helps map the trends and impacts, and then helps communities and other stakeholders to develop a plan to avoid future disasters. And this tool also engages governments so that when there is a disaster, they can request for relief, support, and also compensation that is provided by the government. And this compiling of evidence that happens through the active involvement of communities, it then puts pressure on governments as well as international community to act as per the need of the community, and also looking into the future impacts. Next slide, please. So this is the handbook on your screen that we have developed with support from APN Global. That's based in Japan. And we developed these methodologies, which is now being used in several countries where ActionNet is working. Next, please. So there are 7 steps that we have outlined in this particular toolkit. So let me briefly speak to these tools and steps. So the first one is risk and resource mapping. Now, basically, we are trying to understand the geography of the area and hazards that communities face. So what we do, we sit with the community and then we work with them to map homes and fields and water resources, whatever is available in that area, and we draw a map using local tools, twigs and leaf and or a chart paper pen. And then we do discussion around risks and hazards. So we also look at the past disasters and the risks that they face. And we also talk about who is more vulnerable. So broadly, we start getting into the discussion on what resources they have and then what kind of risks that they are facing. In step 2, we start talking about calendars of change. I think this is where we start relating it with climate impacts. Rural communities who particularly depend on their ecosystem much more, they know and they have been witnessing these impacts. So then we work with them to develop some of these participatory calendars, which are a very effective way for communities to tell stories. Because when we are talking to community, as you all know, it's very difficult if we start with a very bookish or theoretical way of talking. They rely much more on their experiences. So they tell it in the form of stories on what changes they have seen, how there are impact particularly on women or gender differentiated responsibilities that are there, and what kind of threats they have seen which can be linked to climate change. And that's where we look at seasonal calendar, hazard calendar, agriculture. Some crops now they have to sow early or harvest early. If some people have left a particular livelihood in agriculture in this case and have gone for other livelihood options because agriculture became unsustainable. So we really try to capture that information in that second step called calendars of change. Next slide, please. Next slide. It's not working, it seems. Could you please go to the next slide? Yeah, thank you. Now, once we have discussed the hazards and we have mapped the resources, it is really important to identify who are the most vulnerable households and what kind of hazards they are facing, so that in future, we are able to identify those households. I think the presentation is gone. We are able to identify those households. Now, when we talk about vulnerable households, we particularly identify if there's a family that has a person or a child with disabilities or elderly people, or at that moment, if there are pregnant women, lactating mothers, or somebody with mental illness. So we identify those vulnerable households so that we can then understand what kind of support they would be needing when they are hit by a disaster. And this should all go to the community level and government level database on which households need to be supported much more. Step number 4, once we have identified, we try to understand the impact as well as trend of disasters and climate change. So earlier we talked about the hazards changing. Now we talk about the impact. Now, for example, if women have to go far to fetch water or fodder for livestock. So the real impact on their lives and their resources, their crop production. So we now begin to talk about that in a much more detail, and we start looking at trends so that communities are able to now relate it with the larger change that is happening. Next slide, please. Yeah. Now, while we do collect this information with community, it is also important to look at the external expertise. And again, I would refer to one of the presentations in the morning that were talking about both bottom-up and top-down approaches. And this is quite similar. And it becomes very important in case of climate, because we are not only relying on past data, we are also looking into future, which means the climate modeling that has been going on, which projects what's going to happen. As one of the slides I showed, if the production is going to go down by 2030 or 2050, what needs to happen? So bring that external expertise, look at past data, look at people's experiences, but then also talk about the future impacts that are being projected by some of these climate models. And this is where we bring both these knowledge systems together so that we have a comprehensive picture. Now, step 6 gets applicable when there is a disaster. So otherwise we stop at 5 and then we straight away go to step number 7, which is about advocacy and lobbying. Once we have all the information, now it is about working with the government, local authorities to advocate for change. And so that it informs policies and kind of actions and measures that are required. Now, if there is an area which is already affected by a disaster, we take step number 6, where we calculate the loss. And in some cases, it's a slow onset disaster, particularly sea level rise or ocean acidification, or we see landslides happening, so or salinity increasing. So then we do calculate and report loss and damage also to the government officials and share that within the community. Next slide, please. Now, in terms of solution, so my presentation connects very well with what Dr. Andrea presented. So we also talk about organic farming, next slide, where we have seen, and this is coming from experience because I'm also part of this initiative called Satat Sampada. It's a social enterprise based in India, where we have applied organic or natural farming, where we have seen many benefits of that. Environmental protection, we have seen how water usage going down. We have seen how it tackles climate change. So the crop that uses organic manure and organic inputs, and there are no agrochemicals are used, those crops are able to withstand climate change much better. And then, of course, their carbon footprint also goes down. And the food that is grown using organic and natural inputs is also safe for consumption. So if you see that green triangle, which is about environmental protection, safe food, and it tackles climate change, and the brown triangle that you see, it is about how it creates more livelihood opportunities. Because if you do organic or natural farming in true sense, and if you're not using herbicides, then you are also engaging more people in the whole growing system, and also in terms of procurement and further part of the supply chain, which means that you will be able to give more opportunities of livelihood to local communities. And because of this is safe food, it is also able to provide better income to farmers, because the safe food or organic food sells at a premium, and there are people who are willing to pay that premium, knowing that this food is safe, especially the kind of diseases that are happening. In fact, we have seen after COVID hit, the pandemic hit this region, we have seen that the demand for such safe food has really gone up. Now, if you create livelihood opportunities and farmers have better income, clearly it reduces migration. And we have seen many young people who have been associated with us are now not going to the urban areas, and they're saying they're earning much better and living a good quality of life at their homes. Next slide, please. Now, why social enterprises, which is another aspect of my presentation? We need to understand how government investment in this whole area has been going down for years. And of course, we are demanding that government investment into agriculture, particularly public infrastructure, has to increase, and they have to provide support. At the same time, we have seen a purely corporate model is very exploitative. We can learn from the Western countries where there's a whole lot of corporatization of agriculture, where it has impacted land, it has impacted water, people's health, and of course it has pushed small farmers away, and it's a very high intensive input model, which is quite unsustainable and relies a lot on subsidies. Whereas when you involve social enterprises, it is established on the premise of creating an impact in society and environment. So the fundamental objective of social enterprises is not just about making profit, it's about what it can deliver as an impact both to the society as well as the environment. And because these are not a non-profit organization or an NGO, they are not relying on grants, they have a pressure to become financially viable, which means they will always look at the financial viability, which is not about only orientation towards profit, but how do you make profit to become sustainable while also remaining relevant for social and environmental causes. And we have also seen that how social enterprises can genuinely encourage communities to become empowered and self-reliant. Because if communities are empowered and self-reliant, the same thing then goes to help social enterprises, because they also want to be self-reliant. So both are interdependent on each other and on each other's success. And we've also seen how that change process then becomes sustainable, because we are not making farmers dependent on grants, on doles, or on a system which doesn't allow them to think and create their own solutions, which means it's also replicable across the board. Very quickly about this organization, it was founded in 2016. Its mission is to promote, so the name is Satat Sampada, which means roughly means it's in Hindi, and it means nature forever, so that how we can sustain our natural wealth. It promotes environmental solutions. It looks at sustainable food system at scale and to boost rural economy, and also provide healthy food for all. And one of the main characteristics of this initiative is to keep the prices low, so that organic food becomes a new normal. And we go for participatory guarantee system of organic certification, not a very expensive one. I'm sure Dr. Andre knows very much about it, because it's linked with IFOAM and the initiative that they have been promoting around the world, which is also about involving communities. They monitor each other, they support each other. And it's quite successful in many of the areas in India and many other countries. So now when you work with farmers, it's just one part of it. We also have to make sure that the product that we are growing or developing, processing, needs to find a market. And we have also in the last few years have tried to become very market savvy, learning from the market, so that we are able to sell it in a very professional manner. So, while we are a social enterprise, that doesn't give us any luxury of not becoming customer centric. And that's, so you have to create a brand, you have to become visible, and you have to do it very professionally. So there's a brand called Eat Right Basket. Next slide, please. So while we are selling, but there's also a lot of effort going in terms of training farmers on preparing their own formulations and so that they can keep the pest away. There's also effort of promoting more, less use of machine and more handcrafted material, which is also reviving our traditional ways of working and traditional wisdom. And we have seen that when we talk about hand-pounded lentils, for example, or low energy or low heat extraction of oil, customers do understand, and there is a growing market. And we also do work with women farmers and do a lot of sessions. Next slide, please. So this is the online platform, which is, so the website name is eatrightbasket.com, which is, it's a full-fledged website where people can go buy, and the prices have been kept in a manner so that it's not very expensive, which is normally the case for organic products. And that's why it is not able to create that market. So how do we create a value chain which gives much better income to farmers, but prices at a level where middle class can afford? Only then we will be able to expand the market, which is a huge struggle to keep the cost down, because the cost of production is very high. Cost of logistics is very high because we have to rely on our own logistics of using public transport. But at the same time, there are no mandis, there are no major wholesale markets available. So how do you really balance that, where the cost of logistics with those bigger markets, wholesale markets, is very, very low compared to, if we have to procure ourselves in smaller quantities. Next slide, please. Now, this is the last one. And while we have been quite successful in taking that model, but we have also seen that there's a slow growth in customer base because the awareness level is still not there at that level, although it has increased a lot due to COVID pandemic. But people also get very casual. And the kind of customers who are aware and savvy, they are normally young couples. They're also highly mobile. So you turn them into customers and then they move on. As I was just mentioning, that because there is low infrastructure investment by government, there is no market which is purely for organic, which is helping farmers to deal with the logistical challenges. Which means that the cost goes up. And there's a very weak supply chain of fresh products, in particular vegetables and fruits, because the growers are few and they're in remote places, and transporting them in time to reduce wastage is always a challenge. So, and in a country like India, although there's a good railway system, but still, because they are far, and some of the fruits that are not grown in, in all geoclimatic zones, so you have to really depend on public transport system, which often, doesn't really, it's not very efficient at times. The last one is there are a lot of investments happening, when we talk about big e-commerce companies and the kind of service expectations they set, and then you're dealing with the same set of customers, and you are a social enterprise that is paying well to farmers and trying to keep profits low. It's not easy to really invest into advertising and the kind of discounts big companies like Amazon would offer to their customers. So that's a challenge. Having said that, there is a huge scope in this, and over the last few years we have demonstrated and we have seen that model working. So with support from civil society and with support from philanthropic initiatives to particularly take care of some of the challenges, I think there's a huge scope that social enterprises can play a very important role going forward to increase agriculture productivity and deal with the challenges of climate change. Thank you very much.
A solution in India, especially in Delhi, and also you manage that practice into a promising solution, which is social enterprise. And I think organic farming and organic product become more trendy nowadays, and then it has a niche market among a very specific targeted population. And especially I think like during the pandemic, people start to get into gardening, growing their own food. And I think given the situation, maybe it can be easily widespread and then be adopted by other countries. And as I'm sure also the participants here are also shared similar concern and practices with Mr. Harjit Singh, you can address your questions or ideas into the chat box and I read them to Mr. Harjit Singh. But I'd like to comment on what has been presented. I think like making the community to involve into, say, mapping the climate impact. It's a rocky road and a rocky path to take, I think, since they have to understand why they do that, what is the benefit for them, and eventually it is a behavioral changes. And when it comes to behavioral changes, I think it is always hard to do. So please, participants, you can address your question. Otherwise, I think I'd like to ask question myself. We have actually one question from Mr. Velaratne from Sri Lanka, but I think I cannot really comprehend this as short sentence, but I try to summarize. So he was saying, can we organic farming give less harvest and how to compensate? I guess like by doing organic farming, actually you earn less money as opposed to conventional farming. How you compensate that less income? Thank you.
Thank you very much for the question. Our experience has been the productivity or the yield is less, but income is not less. And this is where we have to create market for such farmers who are putting so much of hard work and commitment to grow organic food. So productivity goes down, or I would say yield goes down by 20-30% in some cases. But the kind of price that they can get of the yield is several times, and I'm repeating it, several times of what they are getting in regular market. So the concern is not about less income directly or less production. It is about how the quality product that they are producing can find a better market. And this is where, as I was saying, there is a role of social enterprises, but also government. If you create local markets and make sure and popularize that this food has been grown without agrochemicals and pesticide and they are good for your health, and create a local farmer market, I'm sure there will be many buyers, and we have seen that experiment in different parts of the country. So, and then farmers are able to earn much better than what they get in regular market. So I think we need to look at the challenge of productivity going down slightly, but then income can increase significantly if there is a good market. Yeah. No, in some countries that could be a challenge, but I can tell you the focus on social enterprises, and because they are small and medium enterprises, is actually increasing around the world. So there's this data, from, if you look at developing country, and that's also true for developed countries, it's small and medium enterprises that are providing, bulk of employment in any economy. So while we talk about large corporations, but if you look at the proportion of people who are being employed, it's small and medium enterprises. So many governments are prioritizing to work with small and medium enterprises. And again, I'll refer to coronavirus pandemic. It actually brought the focus back to small and medium enterprises who played a significant role in keeping the economy going. and they were the ones that were also affected. Now, when you are saying they are compared with non-profit, I think there is an increased recognition when there are private organizations or private companies which have a social change as one of their core objectives. I think it's becoming very clear, whether it's in the field of organic farming or, let's say, waste management, which is also becoming a major issue, which is linked to climate change, but overall environmental challenge. They are being recognized separately. They are being included in government programs. They are being supported by government programs in many countries in Asia. And I've heard stories of that from Pakistan, Bangladesh, India, on how these organizations are being prioritized, and they also get recognition. They also get awarded for the good work that they do, which will not be the case for a regular private company, which largely has profit as its motive. So I think it's increasing. There's a shift in government's mindset, and we need to talk more about it.
Then we still have one more question coming from Zagum Sultan. What were the challenges you faced due to the pandemic? I think you mentioned earlier there's actually this pandemic given the advantage to the organic farming, right? So Mr. or Ms. Zagum Sultan, I'm sorry, Zagum Sultan want to know what is the challenges due to the pandemic.
Honestly, I think I could spend the whole day talking about those challenges. The very first thing that happened, the whole logistical system broke down. So as I was saying, we were relying much more on public transport, and we still do. So the whole public transport was stopped, and we were not getting supplies, and farmers were in so much of trouble. They were saying that we have harvested and we are not able to send it to you because some certain things come from far. So we had to tie up with some of the private farms in the area where we didn't have to take the vehicle outside Delhi to procure that. And then we had to send a special vehicle to get produce from farmers, which increased the price, but the shock that we absorbed. So the major challenge was logistics. And initially, as you know, governments did not know how to react. So even the police people were not really aware how to allow these vehicles to pass, and supplying vegetables and fruits and groceries to people's home also became a challenge. And one thing which really we felt very bad about, we have always been using paper bags and avoiding plastic as much as we can, but coronavirus actually brought plastic back, because when we were delivering stuff to them, they wanted to sanitize it, they wanted to wash it, and that was a huge challenge. So we had to change our packing to plastic in some cases. And that was, we felt bad about it, but we were forced to do it. Otherwise, farmers' produce was just lying and nobody was picking up. So it has really brought many challenges, from logistics to how food is packed and delivered. But I think because of the increased awareness, as I said earlier, that change is going to be positive in the longer term. And as people's food habits change and they rely much more on safe food.
Thank you, Mr. Harjit. So we don't have any more questions from the chat box, but I personally like to ask you a question. It was really interesting, actually, how you present to involve the community to map the impact of climate change. I think within the process, they also it also encourages their awareness of the climate change by themselves. But my question would be how you engage them to begin with. I mean, the idea of climate change, organic farming, usually sells really well in a certain population, say an educated population, but now you're dealing with farmer and actually promising them by doing agriculture, you will get better income. How you engage it to begin with?
There is somebody who has to mute their line. There's some background noise. So I thank you for the question, and I think you've actually identified a problem, a real problem that people face when they go to communities. But we have to talk about climate change in two aspects. One, the cause of climate change and the impacts of climate change. When it comes to farmers, they know very well the impacts of climate change. In fact, they know much, much better than us because they're seeing that every day. You know, how there is early flowering, late flowering, less rain, more rain, early rain, late rain. They know that very well, and they see different kinds of pests, or the whole wind pattern changing. They are very aware of the changes. What they have not been able to relate, as you rightly said, because they are not able to connect that with what is causing climate change. They sometimes think when you talk that because of the deforestation that has happened at the local level, that's what is causing climate change, which is partly true when it comes to microclimatic changes in that area. But this is where we have to use certain tools, communication tools, to tell them about the bigger problem of industrialization, of pollution. So that's where, in fact, in Bangladesh, we have seen they use traditional, I'm sure some colleagues are there from Bangladesh, they know Pattachitra, where local drama, local art form, local pictures or drawing is used to communicate. And that is very effective. Different kind of audio visual products on showing pollution from industries. That's when they realize. And my experience is that even if they don't 100% understand those greenhouse gases, doesn't matter. For them, it's to understand that the pollution that is caused by industries and vehicles is responsible. So as I said, they understand impacts much more. And as you also rightly said, when you talk to them to identify and talk about these changes, they're able to internalize it. They're able to change their own behavior, because then they understand the importance of protecting forest and protecting local ecosystems and ponds. And then they also get involved in changing their own behavior as well as changing government's policies. They engage with the government. So I think it's not easy, as you rightly said, but once it is done, it has a much more longer term impact, because then communities are aware and then they make other people aware within the community.
Dr. Harjit, that's actually a very fresh information about how actually a nowadays problem of climate change and also a detrimental effect it given to the agricultural practice. But then the solution is also using a very updated approach, websites, and then also a campaign with the medium and then tools that it close to the community using folk stories and things like that. I think that is really great. So we have come to the end of the session for the discussion and presentation for this third topic from Mr. Harjit Singh. But we hope to have Mr. Harjit again later on in the panel discussion, where we can go deeper on the, I think, oriented toward a solution and action plan that we can come up together. I'd like to move to the fourth presentation of today's conference, but before I do so, I'd like to remind you again to fill the attendance list that has been distributed to you earlier. The fourth presentation will be from Dr. Salahuddin, Dr. Ahmad Salahuddin from Bangladesh. So from India, we move to Bangladesh, and it will be talking about a collective extension approach to climate-smart alternate wedding and drying technology. So this will be another case and a best practice sharing, I think, from Bangladesh. So Mr. Ahmad Salahuddin, time is yours.
Thank you very much. So I'll operate the slides, or somebody will put them.
They're working on a slide.
Thank you so much. I think my task is little bit been taken, addressed already in terms of explaining the context and the global picture by my previous presenters like Andre and Mr. Harjit also. that under which we are operating in terms of global picture and macro elements of climate change. What I'll be talking about is a particular technology that actually has two kinds of advantage for us. In the one hand, it will tell us that how we can reduce the very important resource of natural resource that helps us for agriculture is water. And then there is another side to this technology is how it can also help us reduce the greenhouse gas like methane. So I'll not talk much about the greenhouse gas, but I will talk about basically the water aspects of how it can be reduced by using a simple technology that exists in the system since last 10 years or more. Okay, the next slide. We all know that there are international forums, CCAC and CGIAR program for climate change and agriculture and food security. These, forums, they have their programs like Climate and Clean Air Coalition to reduce short-lived climate pollutants, and they have partnerships with 50 governments and 50 non-state entities within that framework, and it is basically hosted by United Nations Environment Program. And they have 10 different initiatives, and one of the initiatives directly is agriculture. And within agriculture, we have open agriculture burning, and we have, sorry, can you clean this? Yeah, livestock, sorry, the previous slide, please. Livestock and manure management, one component, and paddy rice production. The under ERI, we have this third aspect, that paddy rice production, how we can address these climate issues into our research programs. So within that, as I said, I'll talk about water. So, and I will talk about the story from Bangladesh, actually. So this is the slide that represents that how over the period since 1998, the groundwater situation looked like since 98 to 2018. You can see that there is a, huge, reduction in groundwater aquifer over this period of time. Okay, next slide. So to, encourage farmers to use less water for rice, and to also tell them that even with, without flooding water in the rice field, you can also get the same use, same yield, and same profitability, even actually much more potential for better profitability in rice if you use this simple technology, which is called known as alternate wetting and drying technology. This was actually innovated in early 2000s, like 2004 in IRI and some other countries like Philippines and Vietnam and Bangladesh. So what it does is, traditionally for irrigated rice, we have the mainstream technology that farmer use is flood their field with water for the full period of rice. If not, there is any drought problem or irrigation implement problem, they always would fill up the rice field with different levels of water. But this technology, please, this is the main tool that I need to explain so that everybody who actually do not know about this technology have a good idea about how simple it is. So you have a perforated pipe like this with about 30 centimeter at the top corner at the right. That you can make a perforation of half of it, 15 centimeter, and with 2.5 centimeter distance, and then you keep the half of it non-perforated, and you put it in the field, rice field, up to the perforated area, so that from the outside you can actually watch inside and monitor your water level. So when you put it in the field, in the beginning, if you consider the whole period of rice plantation, when the plant is in the field, in the beginning for 2 weeks, you don't need to, use this pipe, because for 2 weeks, the plant needs to be established. So you allow 5 centimeter depth water for that period. But after that, until the flowering stage, what you can do, you can irrigate up to 5 centimeter and then wait to see that through the pipes that how the water is performing, because depending on the soil quality, it will vary the number of days in which the field will be dry. So until the time you can see some water in the field at the 15 centimeter up to the 15 centimeter below, you can wait for your irrigation. That is the technology. And then when you don't see any water in the hole, then only you are advised to give another irrigation. So this will continue up to the flowering stage. But if you will, yes, you can go to the next slide. So if you use that technology, since last 10, 15 years, we have this general, impact that we confidently say that it reduces water use by 30%, and it can mitigate greenhouse gas by 50%, especially methane, compared to continuous flooding. And then it increases returns also, because it reduces yield. It doesn't reduce any yield, but you can save on irrigation and also on labor, some for some fields. Okay, next. And I'll not talk about this much, but this is an example from Philippines in different regions that the methane emission can be reduced from 65 to 77% if you use this technology, AWD technology. Okay, next. So my main issue here that I want to emphasize is that the technology and the soundness of technology and simplicity of technology and attractiveness of technology is just the one aspect of whether this technology will be outscaled and accepted by the people. But how we put the technology into context, into the way that will be taken over by the farmers, that is a challenge for some climate smart technologies. In that analysis, you have to be very particular about to set up the extension approach around it. So the technology, its economics, or the management practice, all have been very, very excellent in the research field, but it was not being accepted by the farmers to the scale that everybody in extension workers would actually expect. So the policymakers, extension agents, researchers, farmers all accepted its effectiveness. They all thought that this is a good technology, but they didn't adopt it since the experiment was done in Bangladesh in 2016 and 19 period. So agencies failed actually to a large scale until we had this experiment during last 3-4 years. Okay, next. So what we did, we ED has a network of different multi agency network in the northwest of Bangladesh. In that network forum, we presented an approach that didn't exist before, and we presented the technology, and then we actually asked different agencies to work with us closely so that we can come up with a participatory extension approach. And then when we presented that approach, this forum actually accepted that, and they all showed their interest to participate, and they all have played different roles and responsibilities in this. Next slide. So what we did in this collective impact network approach, that we formed an informal network that actually existed before, but then we re-energized, reintroduced this forum. And then a collective approach for AWD dissemination was introduced to the network meeting. There is a sound. Please unmute. Mute, please. Then in 2016 winter season, we first introduced that network into practice, and they approved it. And then network members include regional government, agriculture research and development agencies, NGOs, and one local university. Okay, next. So the difference between this approach and previous approach, I want to explain it a little bit to you. That previously, whatever effort was given in terms of disseminating this technology was from the point of view of research, not done by professional extension workers. If you look at this slide, you will find that, yes, there is a pump in the middle. No, the previous, yeah. There is a pump in the middle, and then you see only 3 fields marked on red was chosen to see the efficiency of the technology. And then they collected data from there that how much water was saved and whether the yield is right and in the cost, etc. Only from that 3 field, and then it was very controlled trial type approaches, and that was shown as a success. But the other plots that are marked here were not usual, didn't accept that technology. That's how that the use of this technology was very, very restricted. It was only individual plots and only few selected farmers from there, and only single agency worked with it, maybe the extension department or research station, but not the farmers association or others. Okay, the next slide. But in this approach, what we did, that we chose a common area of one pump. This is a picture of one shallow tube well. I don't know whether in your context there are something like this as a water, source of water for irrigation in rice field. but this is a picture of Bangladesh. This is actually hugely covered especially in the northwest and other parts of Bangladesh. It's covered hugely by shallow tube wells like this for rice irrigation. So under this one shallow tube well, when we chose that tube well, we actually form a group. Whoever is whatever farmers are belong to that special tube well and using their field water from that source, one source, and then we tell them that all of you have to form a group, and then all of you have to use this technology, because what happens that the previous interaction was only with few farmers, but not with the pump owners, because there is a contract between farmers and the pump owners that they get yearly contract for irrigating land. They have a fixed amount of charge for water. So even if they want to save water, that savings only can benefit the pump owners if they use less time for this pump. So that didn't attract farmers to save water, because when somebody would approach them to save water, they would not find any reason to save water because they were not directly benefited. So the main deal was with the pump owners and then farmers around that pump. So they come to a contract that if we can save water, then that savings should benefit both the pump owners and the farmers. That's how we try to convince the farmers. Okay, next, yes. So what was the elements of this collective approach? So we used that network, and we strengthened that we called it focal area, Northwest Focal Area Network. And then this network viewed the opportunities with AWD. They recognized that, yes, this can be a good approach if we can link this between farmers and the pump owners. And if we can collectively take all the accounts and keep our number of irrigation, keep our account, the cost of diesel or cost of electricity. And then in the end, after the season, we calculate that how much we spent for the last year and how much we saved this year in terms of electricity bill or diesel bill or a number of irrigation. Then that margin could be distributed to the farmers, between the farmers and the pump owners. So they agreed to work collectively for large scale impact. A community practice was used for this approach. And then they also agreed that, yes, under one pump, they should form one group and like a unit of production. And then they're sharing for scaling with all the villagers, because in one village there may be many pumps like this. So this experience could easily be visible by other villagers for other pumps. And even we have seen that simultaneously when they saw this approach being done under the project without any project effort, many other farmers, many other groups are formed spontaneously by the farmers with their pump owners, because they have seen that water is being used less, and the charge could be less as well for them. So that work like that. So to the next, and also we shared that at the sub-regional level and also at the focal area network level, so that other agencies, other area farmers, other extension workers, they can also share this experience and utilize this experience for the next successive seasons. Okay, to the next slide. So, and this is an example that how networks can work, because in the network there are different kinds of agencies. Like I'm talking about Bangladesh Rice Research Institute and International Rice Research Institute. They worked in this network as a technology and capacity lead agency. And then there was a group of social mobilization lead, like different NGOs and government agencies and extension agents. And then we had this impact monitoring lead, because we wanted to do it independently, so that we had one university and one special NGO that worked for us to take data from the farmers and analyze that data to be able to show the benefits. And then we had a communication lead, the Agriculture Information Service, with the media people. They documented this in videos and disseminated this for the national TVs. And the media people also circulated this news in local media and also in the national media, so that it was able to attract many other actors and farmers. And overall coordination actually was taken care of by the network executive. There is a committee. There was one NGO who worked as the secretariat, and the International Rice Research Institute, we actually provided the facilitation support to the network. Next. So the immediate outcomes was everybody was able to see that number of irrigation reduced by 30% minimum, and then reduction in cost of production by 20%, and then various agronomic benefits observed. Like this was not like successive research done on this, but these were actually farmers' observations that increased tillering they have observed, and then less pest and diseases was observed, and also increased fertilizer efficiency they have seen, because they thought that if you use AWD, then you need less nitrogen, because they can see that the color of the leaves are greener than the other fields. And then although it is not found it strongly, but the farmers also thought that they have got 10% additional yield in this practice. And the farmers negotiated with pump owners to charge less rent, because they have shown them with evidence that you have given us 30% less water, so you should be charging us 30% less. So this was not imposed on them, because we actually created that environment so that farmers were able to bargain with the pump owners, and they negotiated at different success rate, because each and every pump group had different experience of bargaining and different experience of sharing this benefit amongst them. And development of organization specific pluralistic extension method, because we allowed all these NGOs to adopt their own approach to disseminate this information, because each and every NGO had their different working modalities with farmers, so they could we allowed them to use that modality to be able to disseminate this information amongst many more other farmers. And farmer to farmer extension happened automatically, locally, and with the neighboring farmers. One farmer group shares experience to at least 3 groups that we were able to get information from. And group tracking evidence they were able to, with records, I'll show you how they did it in reality in their register book, etc., the number of irrigation and cost of fuel, yield, etc. And network as community of practice, sharing and scaling out that I talked about before. And advocacy at regional and national level by network, because this was linked to all the government agencies and public sector, private sector agencies who worked in agriculture were the members of this network. So this was immediately in different periodic meetings, we were able to, disseminate the information and progress and update them with the latest development. And this was an ideas for future sustainable business models in terms of, the credit groups or input output marketing and cropping pattern. These were not possible for us to, experiment in these during this period, but they recognize that, any credit agency, they could make, direct link to this group, and they could also promote different varieties. They could also, talk about other inputs. They could also collectively, buy the outputs from the farmers, and they could also, influence them to adopt a particular type of cropping pattern that extension agents would like to promote in that region. So, and then targeting impact organizations that had the potential to scale it up at the regional and the national levels. Like we have the Barind Multi-Purpose Development Authority, we have Rural Development Academy, we have Bangladesh Agriculture Development Corporation, and many farmer federations that could actually replicate this. And if we say that in terms of network impact, this practice was recognized by CCAC, and they actually awarded this Innovation in Behavioral Change Award to this network for its effort to reducing methane emission in rice production. ERI has been included as part of the largest national network of environmental researchers, which is called Gobeshona under the one university, independent university in Bangladesh. They invited to be part of that network for this work. And then ERI has been accepted as a member of the regional forum for this work, which is called multi-stakeholder platform formed with the leadership of Barind Multiple Purpose Authority. And ERI has been accepted as a member of the advisory committee of IFC Water Research Group that is actually running a number of projects in Bangladesh at the moment because of this, work we have done. Next, please. So there are some examples that how farmers worked and the groups are organized, and how they discussed together, and how they kept their accounts in the register, and also how do they make their resource map to be able to show that how in which field how many irrigation would be necessary to keep track of different levels of land and the requirements of land. So there are a lot of learning with amongst the farmers to make this technology within their understanding, and to be able to utilize it properly in the future. Next, please. These are some other pictures that were different kinds of courtyard meetings and field visits and field days and training, and also at the network level how it was shared. Next, please. This was finally this is the final forum where for the regional impact and national impact we were able to share these experiences. Next, please. So in terms of bigger impact. We are able to communicate to the policymakers that under the shallow tube well, there about 56% land is covered, and 79% of the implements being used for irrigation are shallow tube wells. There, especially those who are diesel operated, they can immediately, accept this technology and get the benefit, and which will be a very, very big impact nationally. And also to the extent to the deep tube wells, where there is provision for, smart cards where farmers can, get their water according to their need. That kind of, areas we can also use this technology easily and get benefit, and that can actually give us a big impact at the national level. Next, please. So just briefly that, yes, this technology is being used in Vietnam, Thailand, Philippines at different, capacity by ERI. AWD is included in Vietnam in the greenhouse gas mitigation targets of Vietnam contribution to the Paris Agreement. It is currently being outscaled as part of the World Bank project. And then in Thailand, we have this a large mitigation project on nationally appropriate mitigation actions. Disseminates AWD supported by laser land leveling in central Thailand. And the Philippines policy guidelines aim to mainstreaming AWD in all irrigation systems of the country. And there are ongoing ERI research in these countries for digital monitoring system, options for sustainable finance, for low emissions rise, and on AWD suitability mapping and assessment of co-benefits. Next, please. So the lesson is that innovation of an appropriate climate smart technology such as this is only the first step to make it impactful. An appropriate multi-stakeholder-led collective approach was necessary to get its full potential. And an appropriate policy framework can help scale it further to get the technology widely used and thus contributes to food security and make it climate smart. I think this is the end of my take. These are the partners who worked with us in this effort, and thank you for listening. You are muted.
Check. Yeah. Thank you
We
very
can't
much.
hear you. Yeah.
Yeah. Thank you very much, Dr. Ahmad Salahuddin from the IRI, International Rice Research Institute. It was a very, I think, like a fresh insight on how wetting and drying technology, AWD, has been implemented in Bangladesh and also adopted in several Southeast Asian countries. So on the chat box, we have received several questions. First from Dr. Asif from Pakistan. The question is, how do you plan to overcome problems like climate change and variations, lower underground water level and losing fertility due to the excessive land use? Any workable action plan? That's from Dr. Asif. Would you like to directly answer that question, or yes?
Excuse me, can I see this question, please?
Sure. Could you share screen, guys? Hold on a second. The operator is sharing the screen. Are we on?
Okay, I can see it from the chat box. The AWD reduces 30% of water use, which is very good. Under what condition? Yeah, as I said, in the beginning, when I said that depending on the soil texture, it actually varies. So my 30% was from the northwest of Bangladesh, and if you look at the literature, that will also tell you that most results come so far actually suggest that we can get 30% reduction of water use for irrigated rice. And actually, there are recommendations that for some soil where the water, retaining capacity is very low, we actually don't recommend AWD. So there are the strict recommendation that there are particular range of soil that should not use this technology. I don't have ready data for that, but you have to be cautious about your soil quality before you do it. If it's too sandy, it will not work. Yeah.
All right. Thank you, Dr. Ahmad Salahuddin. That was a question from Mansur Makmun. And the next question is from Mina Mentari from Indonesia.
Yes. How do you plan to overcome problems like climate change? Sorry?
The previous question, operator.
Okay. Like climate change and variation under groundwater level and losing fertility due to excessive land use. Any workable action plan? Yeah, I think this is one particular problem is being addressed with this technology. It's not actually solving all the problems of soil now. This is only telling you that how we can reduce the water use for rice. So you have to, there are many other regions for soil quality reduction. No? So that this technology can complement to the whole range of that challenges, but not solving all the problems. This is, as Harjit was saying, that how much water we use. Like for 1 kg of rice, we need to use almost 3 to 4,000 liters of water. So this is whether you want or not, farmers will continue to do it unless you give them some options to reduce that. There are also discussions going on in terms of zoning, that where you have a problem with groundwater level, you can actually consider not to grow rice. There are other kinds of discussion, but we are discussing here with the context that where even if you don't want farmers to continue to grow rice with irrigation. So either you give them options to forget about one season where you need, especially in winter season, in the case of Bangladesh, that being also advised by the policy options being taken, that farmers are discouraged to go much more irrigated rice during winter. But still we cannot resist them. We cannot adopt any strict rule not to go for that. So unless and until they're doing it voluntarily and choosing another better option that suits their condition or profitability, we cannot stop that. So within that limitation, what you can do, what alternative you have in terms of advising them for reducing water use. That actually is the purpose of this special technology.
Okay, thank you. Then we can move to the next question. Could you?
Okay. In case of greenhouse and method issue, only to reduce emissions, only the methane gas. How about the other greenhouse gases? Yeah, there. I'm not a that kind of. I'm an extension expert, so there are issues like nitrous oxide. There's some controversy as well. in terms of whether AWT increases nitrous oxide. So I don't want to get to that discussion because I'm not the right person to talk about. Maybe Andre can give us light on that. But for methane, I'm sure that everybody agreed that this is a very strong, there is very strong evidence that it reduces methane at least by 60% or more. So that's the benefit which is visible. For nitrous oxide, I'm getting actually mixed kind of reactions because this is not still established that nitrous oxide actually is increased for AWD use. But some scientists claiming that that is the case. For other gases, I have no information.
From Kausalya Vijayasvira from Sri Lanka. Yes, the question on the screen. What is your experience in adapting greenhouses in tropical countries? Is it cost effective?
I mean, in terms of this technology, I can only tell that yes, this is very much cost effective because what we are doing is already this is being used by the extension agents, but only thing they are not doing is to think about appropriate extension approaches. So you cannot use all the technology, promote all the technologies in the same manner. You have to be able to be innovative in this, that what kind of technology actually needs what kind of extension approaches. According to that, if you can promote it, like here, as I emphasized in my presentation, that the farmers used to have the contract for 1 year, 1 season. No matter how much water you use, they will have to pay a particular fees for that. So if you cannot convince them that you are saving 30% and then you are actually needing to pay only that you can save 30% from your rent to the pump owner, then only you can claim that they will use this technology in the successive season. Otherwise, that will be in vain. That happened in last 10, 15, 20 years that farmer didn't adopt it because they didn't get the benefit. Once you are able to put that into context and bring all actors, all stakeholders under the same discussion, same group, and create that environment so that they can bargain among themselves, only then it was possible to get the benefit. So, and everybody seemed to be convinced that, yeah, pump owners was convinced because their pump was used less, their labor use was less because didn't had to manage too many irrigation, and the electricity bill or diesel bill was less. So it was visible. Everybody can keep the record of what happened to the previous season and what happened to this season. They can easily see the benefit. Only then they were able to, they were convinced and they accepted this technology, and they will continue to use this technology.
Presentation and discussion session for the presentation fourth. So we are moving forward to the last presentation of today's conference with the topic of innovation strategy and regulation for climate resilient agriculture, case study of West Nusa Tenggara. So this will be our own case study from this region that will be delivered by Dr. Ida Bagus Windia Andiana, PhD. He is a lecturer at the Graduate School of Environmental Science, Udayana University in Bali, and also a coordinator of Regional Development Acceleration for West Nusa Tenggara Province. Before we invite Dr. Windya to present his presentation, maybe like we have 1 minute to stretch. I saw that all of you like have like a cramp and things like that, so you can move your arms. I think like you can hold the back of the chair and then like put it there, pull, and then the other side. There you are. And your neck, you can like just move it around like this, and then the other side. There you are. So for the last presentation, I would like to invite Dr. Ida Bagus Windya Andiana, PhD. Time is yours.
Yeah, thank you, my friends. It is very nice to be here and then meeting expert on climate change. Actually, I just got the message from the governor last night to present this presentation. It's supposed to be presented by the governor of West Nusa Tenggara. Okay, next. Yeah, first of all, I would like to introduce the area. Where is it? Where is the West Nusa Tenggara region? So on the top left side, that's the picture of the globes, in which in the middle of the circle is the country of Indonesia. And in the eastern side of Indonesia, there is a small province called West Nusa Tenggara within the Lesser Sunda region. The total population of this province is around 5 million, with the population density is 249 people per square kilometer square. The mainland itself, we have around 280 islands, small islands. Among those islands, 2 islands which were considered as a mainland. The island in the west is called Lombok Island, and the island in the east is called Sumbawa Island. Next, please. Yeah, land use in these regions is basically categorized into 3 categories. The first is for rice fields, composed of irrigated rice field and non-irrigated rice field. And then the second is a non-paddy agricultural land, which is much more than the rice fields. And the last one is non-agricultural lands, which is used for other use such as buildings, roads, etc. Next. And agricultural products in this particular province, the top 10 of them are paddy, corn, soybean, chili, red onion, coffee, coconut in the form of copra, cocoa pods, cashew nuts, and tobacco. Among this top 10 is paddy and corn is our main priority and to be a major livelihood for most of the people in this province. Next. Now, the challenge is how to ensure food security for a growing population in conditions of limited agricultural lands and in the face of increasingly diverse effect of climate change. what we do in West Nusa Tenggara at the moment is to answer that question is to push policies in terms of integrated agriculture and to improve environmental quality index through promoting what we call as Green West Nusa Tenggara and Zero Waste. Next, please. Integrated agriculture basically is a chain of process which is started from selecting best seed to adapt climate change and choosing best cultivation strategies to shorten the planting period and implementing best way to harvest corn production, best process for post-harvest products, until finally it reached the feed mill and sell as a food, high quality food grade. In addition, we also promote the use of crop waste for cattle feed and organic fertilizers. Next, please. Yeah, this is basically the concept of the program is from seed to, we call it from seed to feed. It started from preparing or producing parent seed production, and then until we produce a F1 seed production, and then corn commercial, grain, high quality of the grain for commercial purpose, grain processing, grain storage, and end up with feed mill industry. Next, please. Yeah, the scope of works is basically we try to produce genetically superior seeds, which is well adapted to the adverse effect of the change, environmental change, and high quality of seeds. And we also try to promote the water resources management in order to be as efficient as possible with agricultural mechanization, post-harvest technology, improving market and supply chains, improving data information system, and improving human resource capacity. Next. This one is just actually just the detail of the previous slides. The first one is integrated research station, which is basically a place or a compound in which the genetic testing selection is done, foundation seed production is done, mini seed processing, and center for disease investigation. The output is new variety, parent seed, and new innovations. Next, please. And then it's followed by seed production. Currently, we use total area of 2,400 hectares, which is gradually will be fulfilled in 3 years. It was the program, it has been started since last year, in 2020s. Then the seed production located in several isolated villages to avoid contamination, and a place for special training also for farmers to produce high quality of seeds. Production area completed with mechanization system and water management, particularly drip irrigation and or sprinkle irrigation. The output from this seed production is hybrid corn seed. Next, please. And then the third one is seed processing. The seed processing is a chain of process. It starts from producing fresh seed from field, processing fresh seed from field until seed packaging. The output is SNI standard and ISO certified hybrid corn. Next, please. And then the fourth is corn dryer and storage system. Output again is the raw materials for export quality dry cell corn. This is just example. We put the corn as an example. Next, please. And then the fifth is mini feed mill processing. The output is poultry and livestock feed product. Next. And the most important part of this program is construction of water reservoir to capture the water during the rainy season and can be used in the drought or dry season. So the output is availability of the water in drought season. Next, please. And we also apply or implemented drip irrigation for seed production. The output high precision and efficient irrigation and fertilization system. This is really to use the water as efficient as possible. Sprinkle irrigation also use seed production areas as well as production areas to ensure effectiveness and efficiency in water distribution. Next, please. This is the figures that explain that summarize the previous slides, in which we have research stations supported by the government, operated by private sectors. We have seed production operated by private company. We had combined feed and grain processing supported by government, operated by private company. We have commercial corn production operated by private company, grain processing supported by government, operated by private company, reservoir supported by government, drip irrigation, which is built by the government, sprinkle irrigation also built by the government, and yeah, back to research station. And the final destination for this is feed mill for livestock, particularly chickens. Next. In view of the sites of the process in the province, we try to distribute this program throughout the province, depending on the situation. Yeah, next. Okay, next, please. Yeah, that was the agricultural sectors, the policy to push the integrated agriculture. The second part is the policy from the provincial government to push what we call as a Green West Nusa Tenggara. Basically, these terrible graphs, terrible presentations, is we try to improve as much as possible the forest covered in this province. And we tried to reach the highest level of forest cover in 2023. That's the first one. And how do we do this? Is by doing conventional reboisation and rehabilitation, as well as working with thousands of local community that live surrounding the forest, empower them in order to increase their stewardship to the forest by promoting agroforestry. Some places also we promote monoculture. At other places, mixed planting. And the community that be selected for this agroforestry is we try to select the community that only be grown up with shade, with a tree. And we also try to finding the off-taker for taking the result of the agroforestry, such as feed industry, etc. At the moment, 186 units of community forestry business groups covering 51,987 hectares and involving 37,104 families involved. Next, please. And the last policy, last programs is what we call is a West Nusa Tenggara Zero Waste. Basically, these programs is implemented in addition to clean up the entire cities within the province. It's also targeting to ensure the quality of the water which flows from the mountain to the coastal areas in the province. Our target in 2023 is a reduction of the occurrence of the waste by 30% and handling of the waste by 70%. This is the hardest part that can be done so far, because changing the mind of the people in which the education is not similar, the wide gap, the level of the education between people, and also the wide gap of the welfare, make this program is not so easy to be implemented. And in 2020, the progress only 1.75%, 1.57%. And for handling of the waste, we only able to reach 33.32%. Next. Yep, I think that's all that we can present it. Presenting, probably we better to discuss it if there is any. Thank you.
For a presentation on how West Nusa Tenggara has put a strategic plan in practicing better agriculture, actually. Well, that last presentation closed all the session of presenting session for this for Mr. Andy Lew and also Mr. Harjit Singh, Dr. Ahmad Salahuddin, and lastly Dr. Ida Bagus Windia Adniana. To be prepared, we will orient the panel discussion toward, say, a workable plan that we can come up together as a recommendation of this conference that can be adopted and disseminate by a member of the conference, and also we can apply them to our region or to the locus where we work on currently. And I would like also to ask the help of note taker to really pay closely to the what the presenters about to say, and then to take a keynote from this panel discussion. So the panel discussion Before we go to the panel discussion, we've been following the 5 materials, so let's have a 2 or 3 minutes break, I think. 3 minutes break.
Sarungan ko siya, kaya alam tu Sumbawa, we intan, satotan ko sarea, baremang tu jaga, pameang nenek kuasa. Apa ampun tu sarungan ko siya, kaya alam tu Sumbawa, we satotan ko sarea, baremang tu jaga, pameang nenek kuasa. Osarea, tu jaga alam we samawa. Osarea, Osarea, tu syukur alam we samawa. Osarea, Osarea, tu jaga alam we samawa. Osarea, Osarea, tu syukur alam we samawa. Osarea, Osarea, tu jaga alam we samawa. Osarea, Osarea, tu syukur alam we samawa.
That's the end of the break season before we continue to the panel discussion today. We've pretty much covered every topic on this conference from
The voice is too small.
check. Yes.
Mr. Eric, can you increase the volume?
Yes, I think. Is that better? Check. Is that better? Please, operator, could help me to increase the volume.
Mr. Harry, sorry, we cannot hear. Can you increase the volume?
We were trying to work with the operator.
Yeah, now it's okay. Now it's okay.
All right, so now the volume is clear and better. We have covered pretty much the topics that we wanted to discuss today in the Climate Resilient Agriculture Conference organized by APO and Sumbawa University of Technology, and also the Ministry of Agriculture of Republic of Indonesia. So we've covered first topic from how actually a local innovation established by Sumbawa Technopark, presented by Dr. Arif Budiwitarto, and then Mr. Henry Liu has explained how hazardous our land situation nowadays resulted by the greenhouse gases and also chemicals. And also we've listened to how actually in India there has been a successful initiative to involve community in mapping the impact of climate change, and also tailor that involvement to a social enterprise. And then we also listen to how actually West Nusa Tenggara put a strategic planning into a better farming practices in the region. So for this season, I will specifically orient or drive the discussion toward more workable plan, as I mentioned earlier, or recommendation, say. So I would like first to, so how it works, so I will ask question, and then I think I'll ask each of the presenters or any of the presenters that in favor of answering that question can go directly. So first question I would start is, from all we've learned today, it is evident that the particular issue of climate resilient agriculture practices has not been a public discourse. That's what I understand. It is a topic in the conference, and it is a topic for a certain community and certain organization which concern in the issues, on maybe some government agencies. The fact that most of the current practices in our agriculture jeopardize the sustainability of our environment, this issue, I think, should has been at the top of the agenda of every nation, agenda of public policies and public policy implementation. So my question to all of you, I think, first is, do you think is this topic need to be a public discourses? Or if it is needed, how do you think to communicate it better to the public audiences so public can involve into, say, pressing the government or policymaker into making this into a top agenda of their policies? So maybe I can ask Mr. Andrew Liu first to respond to this.
Okay, thank you very much. I appreciate it. So, in terms of is organic farming capable of increasing world food requirement, I'll speak from my time as the president of IFOAM Organics International, the only global organic umbrella body and global change agent. And we've got a lot of research showing that the best practice organic systems can get equal and in many cases higher yields than the current industrial agricultural systems. The fact is actually broad-scale industrial agriculture is actually amongst the lowest yield per hectare compared to other farming systems. When we start looking particularly at smallholder systems, this is where we've actually done projects. We've got very good data from millions of hectares actually now, showing that where we bring in best practice organic systems, we can actually increase the yields of smallholder farmers in Asia, Africa, and Latin America by up to 100%. It's quite significant. And that's by bringing in polycultures, agroecological systems where we're bringing in multiple crops per hectare. So the answer is yes, we can. It's getting the appropriate system for the countries. But we've got data from Africa, Asia, but also North America now, where we're getting very good data with our new organic systems that we're getting higher yields per hectare than the county averages for broadacre crops like corn and soybeans, for instance. So yes, it is very possible, and in fact it's being done now.
All right, thank you, Mr. Andrew Liu, answering to the specific question about organic farming. Yet, I'd like to also go back to my initial question, that actually, when we talk about all these issues that we discussed today, it is really should be on the top of the agenda of every nation. But yet it is not there yet. And do you think in order to do that, do we need to involve public by making the issue of climate change and specifically to the climate resilient agriculture to be a public discourses, meaning that people talk about it and then they advocate the government or policymaker to make it into top agenda? Do you think it is an important first initial, or maybe in other countries or other places it has been a public discourse already, but here in Indonesia at least it is not there yet?
It's a very important discourse because, and there's a few reasons. One is that, agriculture at the moment is a leading contributor to climate change. Consequently, many governments do not want to put it on the agenda. I know in my case, being working in the United Nations system, particularly when I was president of IFOAM, and we were involved in the Farmers Forum. We found it very hard to get agriculture into the actual Paris Agreement. In fact, if you look at the original Paris Agreement, the word agriculture is not even in it. We finally got it in the Bonn meeting in 2017. So we've been left out, mainly because of the fear that if we bring agriculture into it, because it's a major emitter, we're going to lose production. However, we need to have this discussion because, as I've shown with the regenerative and organic systems, I gave examples of, we can take agriculture from being a major emitter to being a major solution with the right methods. We already have them. And by getting them onto government discourses, which we have in my country in Australia, which fortunately now President Biden has done it, Norway has done it, New Zealand, we're getting it into the European Union, and we're getting Mexico, for instance, is taking it up now. Other countries, by getting it there, we can actually start getting good research, good science into changing agriculture. So we are now part of the solution. The good news is with these new techniques, we are increasing production and reducing production costs and increasing the return to farms, in other words, prosperity to agricultural communities. So this is win-win-win, and it's why we need to have further engagement with these best practice systems to show that it can be done. The other one, which is really important, which Harjit and Ahmed talked about, is yes, we've got these systems, but how do we scale them up to get adoption? And that's where we've got to work with communities and participatory systems and farmer to farmer. And once again, we have good evidence on how we can do it and how we can do it to in the end, go to hundreds of thousands and then millions. And really, we've got half the world, billions of people are actually farmers that we need to get to.
Interesting. Thank you, Dr. Andrew Liu. And then I would like also to hear from Mr. Harjit Singh, if you may.
Sure. No, I would like to add on what Dr. Andrew already said. So I think we need to also understand the political economy behind why organic farming is not getting that kind of support. The reality is that big agriculture corporations and big farmers are not allowing government to change its policies or orient its measures towards agroecological or organic kind of farming. If you look at subsidies, the government subsidies are largely going towards agrochemicals, those pesticides and fertilizers, and not for organic or agroecological farming. I think that needs to change, and we need to realize that the reason agriculture has high emissions because the role of agrochemicals and pesticides and fertilizers that are used. So how do we step away? So it's going to be a win-win situation, as Dr. Andre was also saying, if we promote and the interest of smallholder farmers, and if we promote agroecological systems, that will not only protect the environment, over time that will increase productivity and give so many benefits to the economy, to people's health and nature. So that's where the focus has to go. Let's also understand that common public will not be able to understand those nuances. So I don't think it will become a public campaign of sort, where general public starts demanding such action. I think this is where the role of academia, the civil society organizations, private sector, social enterprises, they have a huge role to play to shift government's attention towards agroecological or organic farming. Thank you.
Thank you, Mr. Harjit. So it needs to be the top priority of a government agenda, but the political economy behind it doesn't allow it. And then this is a specific agenda of academias and social enterprises and think tank organization and organization alike, for example, Technopark and such. So talking about Technopark, I'd like to address the same question to Dr. Arif Budi Witarto, but specifically to what need to be done by like Sumbawa Technopark, for example, to advocate this issue so it become an agenda for local government, since this Technopark is specifically funded by local government. Dr. Arif?
Okay, thank you, moderator. So, the Technopark function has been decided by the central government is creating the small medium enterprise based on technology, or we call it startup companies. So as institution, actually we do not engage on this kind of discussion because it's out of our function. However, as personal, because we also have a regional research council where I'm also appointed by the mayor as the member. We discuss a lot of this topic, and this council function is to advocate any issues for the local government. So I like to mention this different side from our institution, which is not our function. However, as a personal, we think this is very important. So I use the opportunity as the member of a regional research council to actively promote this for the government, local government especially. Thank you.
Thank you, Dr. Arif. And then I'd like to also get a take from that answer from that question from Dr. Ahmad Salahuddin, maybe.
You asked me about Technopark.
How to actually advocate these issues so it become a top priority of government agendas.
Any technology or about Technopark?
The first is about the climate resilient farming practices.
Okay, yeah. You know, the we operate in a system, in a world where we contradict ourselves. It is not consistent in terms of, if you look at FAO now, for instance, FAO, if you consider FAO is the world leading agency in agriculture, we should, in kind of United Nations agency, which looking for setting the agenda for next round of technology recommendations, etc. They have adopted this agroecology, decade of agroecology and family farming, etc. But we don't see that reflection in our national government policies. No, they can celebrate the day or event or have seminars, etc. But it's difficult to see that how it is integrated within national government policies, and the national government policies are guided again by their own framework of developing and implementing. So this is this mismatch, and also between, if you hear about Mr. Harjit Singh, they have a complete a cycle of how they can start the participatory reflection from the farmers, and then ending up with supplying that product to the market for consumers. So they have maybe compared to the government delivery system or research and development system, it may not be that big, but they have shown these examples. But there is no mechanism that how that can be mainstreamed. But at the same time, we are seeing that a lot of development, as my Andre perhaps talked about, different global, voices that are coming in and really recommending things and adopting things that are very encouraging. And even in India, you would find that agroecology movement or natural farming movement is very important now in at least in 11 states. So we see a lot of good things are happening, but we are yet to see that how that matches to each other, how that complement to the government policies, and complement each other and be compatible for farmers to meet up the demands and challenges for the next round of things that world forums and different scientific you know innovations are coming in. So we have to be pragmatic at the same time, that how we can within our little scope that we have at the individual level or organization level or farmer organization level, to bank on and see that what entry points we have and try to adapt to that situation.
It's fine. So I'm happy. Yeah, I'm very happy to speak on that because, and you're really asking two very important questions. So governments have very different agendas from farmers, and for the governments, for instance, they've got their commitments to Paris, for the Paris Agreement, they've got NAMAs, and we're actually given some good examples today about how it worked. For instance, Dr. Ahmad gave some good examples on how to work with governments. So it's how you frame it in terms of their climate change, but the other area are the same sustainable development goals as well. All governments have signed on to that. So we need to frame it to governments in a language they understand and how there are benefits. And very importantly in Asia is that, how that they can now access the Green Climate Fund, where there are now billions of dollars to bring money into their farming communities and revitalize their farming communities. So that, here's an opportunity for them to adopt, suitable technologies. And I would argue one that would resonate all through Asia is the alternate wetting and drying, since paddy rice is such rice is such an important crop. and it's a major producer of methane, and we have very good data there that we can significantly reduce methane with this very simple technology. The other one, which was mentioned, was nitrous oxide. There's some studies showing that they do go up, but we also have other studies showing how we can reduce it. And we won't waste time today on that, but you can reduce all greenhouse gases and increase soil carbon through these technologies. We do have good research now on how to do it. The other part is one thing that governments to do it. It's one thing to have good research, and once again, I thought Ahmed Saladin's presentation was a very good example how you get the research, but it won't get taken up because of problems. And this is where we have to work with farmers at the community level. And Harjit's presentation is a good example of that in participatory systems. You know, that's one of the things that we did in iFarm, is get these participatory guarantee systems where we work with farmers, we empower farmers to take control of their systems, be the agents of change. And we work with hundreds of thousands of farmers very successfully this way. We do have these models, farmer to farmer, community empowerment. And the other one, once again, which both Harjit and Ahmed spoke about, was where the farmers actually get a financial benefit. That is the real driver. At the end of the day, they're not going to change if it's going to cost them and they're going to get nothing from it. We give them a benefit, a financial benefit, and they are better off. That will be the driver. And we have those drivers. So these things are in place. It's just about how we manage it and how we do it. And in the end, that gets down to local conditions. There is no one size fits all. It's not even saying that every country is different. As we get to different provinces, different states, different regions, there are different issues. And we really need to work at that level and work at local government. And I think that's one of the things that Arif was talking about. And our colleagues in Zimbabwe, we need to work at local and regional levels and empower at that level. And that's when we will get the success, we will get the uptake. That's not for me.
Thank you, Dr. Andrea Liu. And I'd like to also, since we have a representative from the government and also the coordinator of development of a regional agency in Nusa Tenggara Barat, so Mr. Ida Bagus Vindya, maybe you would like to respond to how we move forward to first advocate this issue to become a governmental agenda, and second is how to involve farmer or to change the ways of farmer practicing their current practice in agriculture to a more climate resilient one. Please, Mr. Vindya. You're still mute. Could you check the audio first? Thank you.
Okay.
Thank you.
Thank you. Yeah, based on our experience, I should say that we have to have bunches of strategies, so not single strategies. Yeah, my focus on farmers. Yes, I agree with the previous speakers, and also local government. Yes, but at the same time also with the central government. For example, yeah, sometimes. In the case of West Nusa Tenggara, we want to do something good in the term of environment. Yeah. Unfortunately, when those programs is not aligned with the central government, we will not have enough financial support to run this program. So for me, it has to be not both sides, but every side. So we have to promote it, advocate it from all layers of the government, as well as the community farmers. Thank you.
Following to that answer, I'd like to ask another question. So, as other presenter mentioned earlier, Mr. Arif Budi Witarto mentioned that actually bottom-up solution was not that successful. So he proposed a top-down solution. And then Mr. Harjit mentioned also what he has been doing in India, actually like a bottom-up solution involving the community and starting from the very own community. But then there's has been not enough infrastructure support from the government. Do you think that how it works? Pardon my ignorance. Actually, I think that the government has all the authorities and regulation, but why that we have not been successful in changing the ways of farming while we have the authorities that we can enforce actually?
We have the government have the regulation, the government have the authority, but the real managers, day-to-day managers, for doing something in the field is the farmers. So it has to be both sides. So, well, we have plenty of government regulation here, but if we examine that regulation, it's only few applicable in the field. Only few really accepted by the community and run by them. In few of the agricultural production, for example, we will be very happy to promote the organic farming, for example, because we understand the organic farming is much better than when we use non-organic farming in terms of a lot of things. Yeah. But when the farmers consider the yield result is much lower, much less than the conventional farming, then it's difficult. So for me, we have to do hard work for both sides, bottom up and top down. I think that's for me.
Check. Thank you, Dr. Vindya. Then I'll move with the same question to Mr. Harjit Singh. I think you have a good case from India, and then you can share with us.
Thank you very much. No, I would agree with the challenges that Mr. Vindya is talking about, and if I may offer a few suggestions, the reality is that farmers are looking at yields right now, and in fact, it has happened because over the years and decades, there has been a lot of awareness and pressure on farmers to adopt agrochemicals. I remember cases from India where when it was so-called green revolution, they were lured to use these agrochemicals and they were offered many freebies to do that. And then they could see that yield going up. But we have also seen the downside of green revolution where soil quality has gone down. There's a lot of degradation. There are a lot of diseases. So what we need to do, as Mr. Vindya said, there also has to be awareness within farmers on the long-term implications of using agrochemicals, and then there should be some support from the government. So when temporarily the yield goes down, how do we support those farmers during that transition time And as Dr. Andre was sharing several examples, that when the soil quality improves, the yield can match that level and can go even beyond that. And I think for farmers to understand and for governments to understand that from a long-term perspective, from climate resilience perspective, that's the direction to go. Yeah, agreeing with Mr. Vindia that we have to work on both sides and bring both farmers and governments and other stakeholders together.
All right. So I'd like to ask any other presenter maybe would like to voluntarily take an answer to this question.
Yes, if I can add 1 or 2 points, we have to, build some kind of confidence between different stakeholders. At the moment, what's happening, like food security, for instance, is a huge issue for the national governments. So they're always nervous if the production is gone or if there is a big, disaster happens, or if there is a big shift in their policies suddenly. So they cannot take the risk of, having this big shift in policies within a short period of time. So they would not go for your recommendation to adopt organic in every part of the country. They would still talk about these green revolution technologies to ensure that the yield is up to optimum and there is no problem of food stock in the country, especially in this volatile world when many countries can instantly close their market for export. There is more risk now with the pandemic kind of situation where at any time, India can stop exporting rice and China may suffer only because they have big deficit of rice. So this is very vulnerable. So this the system of minimum, surety about the food security has to be maintained. That is for sure. But at the same time, if you look, if you talk about Bangladesh, if you look at the people who are producing rice, they are small farmers, marginal farmers, and mostly poor farmers. They are producing rice, but that profitability, because of these green, revolution technologies, is very low, especially for these irrigated areas. They are even sometimes they go for they don't have any benefit. So actually, what happens is that if we consider not to show the yield as the major factor, if they look at the profitability as the major factor, then the scenarios can be changed drastically, because they're using too much inputs, because they're using too much water, because they are using too much pesticides, their cost of production going high. But if they were protected from the point of view of food security, they could actually be encouraged to take a lot of other alternative technology that suits to environment and climate smart. So these things has to go with the a kind of horizontal level with all the stakeholders together. And if you see the democratic system, if you see the lack of very smart local government system, and most importantly, if you see the lack of farmers organization to bargain with with the government, is one of the major problems there, where we can't actually hear the voice of the farmers. We can see the huge farmer movement in India, which turmoil the whole politics. And if you finally find that yes, farmers have won and they were able to, insist the government to take policy in favor of them, that can actually change the many things. So there is nobody who takes care of the farmer interest in many different countries. They're not organized and they cannot put their agenda into the front, and that is why it is a huge problem that we actually sometimes don't know exactly what farmers want. That I don't know who will take care of that, and the politics has to be blamed for that. But we are not in a position to talk about that because we are not politics. We are only working in the science and then development. So there are a lot of mismatch to really tackle this kind of problems within the system. Thank you.
Thank you, Dr. Ahmad Salahuddin. Maybe Mr. Arif Budi Witarto want to add to what have been said? Check. Mr. Arif Budi Witarto, maybe you have something to say about what we've discussed? Specifically, maybe towards leveraging what have been done by the Sumbawa Techno Park. If you have something to say about it.
What is the question, please?
The initial question was what needs to be done in the government level, for example, to advocate this issue, the climate resilient agriculture issue, to be the top agenda of government. That first, and the second is how actually we can encourage farmers change their behavior to adopt new technologies, for example, innovation as you've done with the Technopark, for example, and a better way of farming.
Okay. So in my point of view as a facilitator for growing innovation, we believe that in every condition there is opportunity. So also about this climate change, I think it must be an opportunity also, like we produce some product with more added value. So that's the our side. I mean, we can find some technology introducing to the farmers, and they create some new products with better added value, like producing organic products, whether it is agriculture, aquaculture, and others. So my answer is there must be always an opportunity for a specific challenge, and that's something that we have to find out. And it is our position to help these farmers or entrepreneurs try to do this in Sumbawa. Thank you.
Check. Thank you, Dr. Arif Budi Witarto, for your insight. And I think we've come to the end of the panel session. But before we end the panel session, I'd like to give all the presenters maybe a chance to say 1, 2, 3 lines about takeaways, for example, from this conference, what, especially on agendas moving forward from this conference. I'd like to start from, again, Mr. Andre Liu.
Thank you. Firstly, I'd really like to thank the organizers. This has been, I think, a very productive conference. And from my point of view, I think one of the things that has been very clear is there is no one size fits all. We have to have a diversity of solutions, and we need a lot of them. And they're going to have to be different ones for every region. And as everybody said, we have to work top down and bottom up. And that's central government to local government to community groups. But really, I think in the end, the most important people in this debate are the farmers. They are the people who are producing the food and the ones who will make the difference. If they do not change, farming continues to be a major contributor to climate change. So it is critical that farming changes, and that can only be done by farmers. And we have to give them the incentive. And the most important incentive is that we have to change farming. So it is profitable and it is a profession that people want to do. At the moment, all around the world, we have a farming diaspora. We're losing farmers, and young people don't want to be farmers because they see no value in it. And we have to turn that around. So really, the focus is on farmers and making life more profitable for them and showing them that we do have these solutions that will increase yield, lower production costs, and make farming a worthwhile profession.
Thank you, Dr. Andre Liu. And then I move to Mr. Harjit Singh, please.
Thank you. Let me also add to what Dr. Andre said. Yes, there are solutions, and those solutions need to be supported to be scaled up. Agreeing that there's a lot of diversity and we need to try and see what works in different situations, which clearly means that farmers, government, civil society organizations, philanthropies, and consumer groups must join hands to understand the relationship of climate change and agriculture and transform the way it works for both nature and the people. Because what we do in agriculture affects nature, and the destruction that we have already caused to the nature is now affecting agriculture. So we really have to relook at the relationship between agriculture and nature and re-establish that relationship so that it's all sustainable.
Thank you. Mr. Ahmad Salahuddin? 2 to 3 sentences.
Yeah. That's the problem. It's a huge issue. We cannot complete anyone to this. No, perhaps for research and development community, we need to be more an expert of how we can go for advocacy and bridging between different complementary and competitive forces, like if and reduce the contradictions between us. We are at the same time celebrating Organic Agriculture Day. At the same time, we are, bringing in maybe multinational corporations for consolidating land. And at the same time, we are celebrating decade of family farming and also agroecology. So these are all full of contradictions, and we need to be more agile in this to actually help different stakeholders to come to close to each other. Thank you.
All right, thank you. Moving forward to Mr. Arif Budivitarto.
Yes, I believe in this era, any sort of technology is available. Even farmer can access through YouTube, for example. It's very easy. But the problem is how to create products using that technology which is affordable by consumers. So that comes our job as a Technopark manager, is to help them not just using technology, but to produce some product which has added value to them So as the previous speaker said, that the farmer must receive the most benefit, especially in this climate change period. So that's our part of contribution in this field.
Thank you.
Thank you.
Thank you, Dr. Arif. And the last from Dr. Vindya. 2 to 3 sentences too.
Yeah. Well, I'm just learning now. I think I've got a lot of good material today, and then surely I will propose to the local government of Western Nusa Tenggara Province to do something based on the information that we gained today. That's the first thing. And the second thing is I believe that still many more people out there, well, they do understand the impact of climate change, but very superficially. Yeah. Probably the education need more targetable. For example, for the leaders of the country, leaders of the provincial government, leaders of the district agency, and the farmers, that should be designed differently. So they will learn themselves and at the same time also doing something that is promoted to reduce this effect of the climate change. I think that's from me.
Thank you,
Thank you.
Dr. Vindya, and that's all from our presenters today. Thank you to Dr. Arif Budivitarto, Mr. Andy Liu, and then Mr. Harjit Singh from India, and then Dr. Ahmad Salahuddin from Bangladesh, and Dr. Vindya Andiana from West Nusa Tenggara. It has been a delightful time to host this conference, this discussion of the conference today. And I'm not going to summarize what have been said and discussed in this conference. I'm sure you all have your own takeaways. But as a result of this conference, we will have our recommendation written and summarized, and later on will be circulated to all of you. And I'm Eric. Thank you very much for your participation today, and have a good rest of the day. And I'd like to call the Master of Ceremony to continue to the closing session. Good afternoon from Sumbawa.
Well, thank you, Mr. Eri Sofiatri, for leading the discussion. And now, before proceeding to the next session, I would like to invite Dr. Tanvir to give some announcement, especially to the participants. So please, Dr. Tanvir.
Thank you very much, Ninyas. Actually, I first like to thank Mr. Eri for your very much proactive and very supportive role to coordinate the panel discussion. It was really interesting. And what Vindya said, actually, I personally learned a lot from the speakers. And particularly, I like to refer when Andre said that local and regional participation, particularly in the community engagement, is very important. And what the Vindya said, that the education and awareness for the policymakers and or the community people, that's also very much this discussion in the future point of view. So actually what we decided that after compilation of this all recommendation, we will share those things to our participants and the resource persons. And of course, the NPOs for their consideration. This it's a really very big topic, and what Salahuddin said, it's probably difficult to compromise and bring all these important topics in this only 4 hours discussion time. But what we like to share this conference, that there are many opportunities that maybe we can utilize as a climate resilient agriculture perspective. We are not like to limit it to only organic, not only agroecology, but it can be depends on the region perspective and different consideration like food security, long-term perspective, climate resilient issues, and of course, the overall government policy as well. I like to thank to NPO Indonesia, the University, Teknologi Sumbawa, the team for their active participation, Ministry of Agriculture, and all the participants and the resource person, of course, for their valuable time and inputs. There are 2 announcements actually I like to give you that probably you already received the Qualtrics survey by email, and you have to fill this survey. And this is important for getting the certificate, particularly for the participants. But the organizers and the resource person, we are also seeking your cooperation for filling that survey. That will help us for getting much better program in future. Not only this topic, in the other digital online programs. So if any participant, if you miss the email, please let us know, me or Eriko Saito. We will again send you the survey. And finally, the certificate, we will send you your respective NPOs as soon as possible after getting all the survey results, and we will keep in touch. So this is all my few words, and I like to thank again everyone for your active participation, and I like to hand over to Nintias. So thank you very much.
Thank you, Dr. Tanvir. Before we end this conference, allow me to invite the Director of the Bureau for International Cooperation, the Ministry of Agriculture of Indonesia. Please welcome Dr. Ade Chandra Dijaya.
Thank you. The Honorable Bapak Fahru Rozi, Director of International Productivity Organization, Bapak Hairul Hudaya, PhD, Director of Sumbawa Teknologi University, Bapak Dr. AKP Mohtan, Secretary General of ASEAN Productivity Organization, representative of the West Nusa Tenggara Provincial Government, distinguished resource person, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, selamat siang to all of us. It is a great honor, of course, for me to have the opportunity to address this conference on climate resilience that has enabled us to gather here with all resource persons from different background, including scientists and policymakers, to share views on how we could deal with the impact of climate change on agriculture. I think we all could agree that climate change is a complex subject, and its impact on agricultural sector has long been highly visible. Climate change can disrupt food availability, reduce access to food, and affect food quality. For example, projected increase in temperatures, changes in precipitation patterns, changes in extreme weather events, and reduction in water availability may all result in reduced agricultural productivity. Distinguished colleagues, ladies and gentlemen, the whole session of the conference today, I think, have brought about many issues to our attention. And I would like to congratulate the organizing committee of this conference on ensuring high level of participation from the whole participants. There has been an intensive discussion on the various aspects of climate change impact on agriculture, covering impact assessment, adaptation and mitigation measures, policies and institutional setting for promoting climate resilient agriculture, as well as ways such as extension to encourage farmers' adoption of climate resilience, such as organic farming system. Taking into consideration that the diverse impact of climate change on agriculture, which vary from one country to another, the last point that still left with us now, I think, is how we could customize all those lessons from this conference into 14 different country-specific settings of the participants who have been taking part actively in this conference. I would leave this point with all the 81 participants to further digest all this lesson and articulate it in a concrete plan of action for implementation that is, of course, should be locally suited to their each country specific context. Distinguished colleagues, ladies and gentlemen, I think I should conclude and allow me to again extend my sincere appreciation to the organizing committee of this conference for the excellent arrangement, and also to all the resource persons for sharing your knowledge, and also to all participants for your active participation. It is my hope that the spirit of friendship that has been nurtured during the conference will be continued and further strengthened. By that, then, I would like to officially close the APO Conference on Climate Resilience Agriculture. And thank you once again for being attentive in this program. Thank you.
Thank you, Dr. Ade Chandra Dijaya. So, ladies and gentlemen, we have come to the end of the Conference on Climate Resilient Agriculture 2021. On behalf of ASEAN Productivity Organization, the Ministry of Agriculture of Indonesia, and Sumbawa University of Technology, I would like to express our gratitude to our presenters and all the participants. We do hope this conference will be extended collaboration among us to tackle the most pressing issues of our society. While signing out from the conference, please enjoy the company profile of Sumbawa University of Technology. I'm Ning Tias. I wish you have a great rest of the day.
Indonesia is an archipelago country which consists of 1,000 islands, and it is also known as the 4th populated country in the world. One of the little unknown islands called Sumbawa is part of it, and located in the middle of Lesser Sunda Islands, with Lombok to the west, Flores to the east, and further to the southeast is Sumba. Universitas Teknologi Sumbawa, UTS, located in the rural setting area of the city of Sumbawa, has become a comfortable place for learning for students and to become well-rounded and beneficial for the universe. UTS has postgraduate programs in management and also undergraduate programs that consist of 6 faculties: engineering, economics and business, agricultural technology, communication, biotechnology, and psychology. In total, UTS has 14 study programs. UTS is offering fully funded scholarships for undergraduate and postgraduate programs for international students through Global Ambassador Scholarship Program for 2020 to 2021. This program has attracted 2,477 applicants nationwide. Supported by proficient lecturers, graduated from national and international reputable universities, makes UTS adaptable for global needs. The students are encouraged to explore beyond their limits and actively participate to the national and international events. By taking part in organization, it helps students to enhance their school experience and to become well-rounded individuals. UTS academicians are actively participating in various competitions, both national and international, such as research grant competition. UTS is holding the 183rd place as National Webometrics and 6th place in the Nature Index for Research in 2020.
Sumbawa University of Technology has a vision of being an enjoyable and comfortable home of learning to well-roundedly grow as human, benefiting the universe. We offer a global perspective and rooted practice to academia through learning, research, and community services. UTS is the right place for you to explore your potential, connect you to the emerging world, and give back the benefit to the society.
Furthermore, UTS is ranked second best university in West Nusa Tenggara. One of the key components for receiving all the achievements is that UTS has built solid collaboration with national and international institutions. Join us to grow and to be more contributive to the world. Sumbawa University of Technology. Grounded and global.
Sarungan ko siya, kaya alam tu Sumbawa, we intan satotan ko sarea parema tu jaga pameang nenek kuasa. Apa ampun tubuhnya, tulen ada dalam balik, bosan jalip para magang kita tusuko paririga magoka Samawa O Sarea Tu syukur alam we Samawa. Sarungan ko siya kaya alam tu Samawa we intan satotan ko sarea barema tu jaga pameang nenek kuasa apa ampun tubuya tuin nada dalam balik bosan jarib para magang kita alam we Sumbawa, o sarea, tu syukur alam we Sumbawa. Sarungan ko siya kaya alam tu Sumbawa we intan satotan ko sare